What's going on? Welcome to Go Playground, where curiosity meets code. Whether you are fresh-faced developer or seasoned pro, join us in this into the world of Go programming. Let us dive in and unleash the potential of this versatile programming language together. As you can see on my screen, I want to start with development environment. How are you going to set your development environment? In chapter 1, I'll explain how to download the Go from the official website. There's a link there. I leave the link description below my video. Go to the website, download the Go. Go is an open source programming language that make it easy to build simple, reliable, and efficient software. Installation. How can you install Go? Installation of Go is easy, as you can see, for both systems, Mac and Windows, also Ubuntu or Linux. You can download setup file from Go website, run and follow the commands. The next step is to configure Go root path for Windows platform. You can add Go root variable on the environment. For Mac, Linux users, you can do it in your bash profile. So for Windows platform, you can add Go installation path. For instance, my Go installation path is C. Then you go to file Go, then the bin. That one is my path. So go to environment and create a new path there. You can type environment and search the environment in your computer or desktop. Then the next part is, after you have configured, you can verify. It is good to verify. You have to run Go version by typing this command on your terminal, or CMD for Windows, Go version. So the output after you have typed Go version is this for both systems. A sample output for Mac OS is Go version. You see Go 1.4 that time, but I think this time the Go has improved. It is 1.22, I think. The output for we do the same Go version. Then you will see the version of the current version that you have installed in your machine. And people or my student would like to know what is the best text editor to use for Go programming language. So I have list of Go text editors for Go programming language. The way I have arranged them is according to my preference. I don't know which code editor do you use, but for me, I use mostly Visual Studio Code. As you can see, Visual Studio Code, I have put the link there. I leave the link below my video. There is a Vim, there's a Nano, IntelliJ, Sublime Text. They are all good text editors according to your own preference. And let us dive to Hello World in Go programming language. Thank you. Hello, good people. So in this Hello World using Go programming language, it is like fundamental to every programmer that want to learn any programming language to start with Hello World in any language. May it JavaScript, may it Python, may it Rust, Ruby or Rails. Writing Hello World makes you to understand the beginning syntax of the language. So I would like to take you through the Hello Go or Go programming language Hello World. This is it. You start by package. I talk about the package as you continue. Package main. So after package main, we have to write the function func. Like func it is like function, the way you write JavaScript function, the way you write Ruby on Rails def, the way you write Python def, the way you write any other function in programming. So in Go, the syntax for function is func. So func main, then we fmt, this is a standard library, print ln. You can see my print start with capital letter P is capital, then print ln, print line. Okay, then I type hello world in Go programming language. Okay, so when I want to run this program here, it will not run because we have an defined fmt. So to define fmt, we have to import it. So import fmt. Note my strings is between, there is a double quote. If you use single quote, it will not work, it will give you errors. So when I want to run this program, because I have now cd to hello world, so I can go build first. I can build go build to give Go time to build, to check if there is error on the program. So if there is no error, it will allow us now to run the system. So go run main.go. So in our case, it is not main, it is hello. .go. So it is go run hello.go. So go run, then we target the file that we have, that package, we have the code, the file that contains that code. So the file that contains our code is hello.go. So when I click that one, I expect hello world in Go. You can see. So it is simple to write hello world in Go programming language. Thank you. Hello good people. In our previous lesson, we learned about how to write hello world in Go programming language. So today we are going to study about variables. So the first question is, what is a variable? Variable is a container that stores data in a computer memory. Variable is it can vary, it can be changed with time. You can change the first variable to the final variable that you want to change. So variable is something that stores data according to what data is assigned to it. So I've started by creating a var demo file, then I've created main Go in the var demo. So in our to start writing our code, remember that we have to start with package main. So this is it, package main. Not package var demo, because I've named my file main.go. Then we have now to start declaring our variables. Remember, so val in Go programming language you use val, you can use const, but there are so many ways to name a variable in Go programming language. So the first way is to start by, let me declare the func main. The first we start by val, then your variable, you can see my val, then you can say the data type of your variable. So I'll talk about the types in Go programming language. We have int, we have float, we have strings, we have uint, we have channels, there are so many data types in Go programming language. So to declare a variable in Go programming language, because Go is a statically typed language, you have to tell Go which type of variable you have assigned or you want to declare. So you declare that my val, then you go to the data type. So the data type, okay, let me comment this line. Like that. So val name string. So we have now told the Go that the name should be a string. So the moment we declare a variable for the name should be string, like this name Mike. So the Go will not complain here because we made a mistake for this one. Let me remove this one and remove this one as well. This one. Copy this one inside this one. There we go. Okay. So the Go is complaining that we have declared a variable but you are not using it. So we'll come to use the variable. So the following, let me show you a simple script to declare some variables. So val string, you can see version string. You can do val m int. You can do another one like mm. Maybe mn is a multiplication of nm, and that this one is a float. 64. You can see 64. Okay. As well, you can declare a variable like this. Val. Okay, declaring a multiple variable in one val. You can say name string. Okay. You can say email. Email is string as well. You can say number, phone, or age int. Okay, so this is the first way to declare a variable. As you can see here, this is the first way. This is the first way. Way to declare a variable. This is the second way to declare a variable. Okay. So we want to assign our first variable their values now, like this one. So string, nm, mn, name, string, email, age, int. So this is simple. You can start by doing this. I will say string. Can put it to hello. While what is the n was an int. You can put it. So m 15, can also give m, another variable like 20, can as well give m 15. Okay. We can go ahead and also declare the name for this part here. But before we do that, I want to show you another option to declare variable. So the another option to declare variable comes, there's a Go syntax that you use colon equals. Okay, colon equals, like instead of now writing string hello world string, you declare the var string var nm int. You can do like this, like string, you can say string, or let me use another name like country. Then you can say USA. Okay. You can say as well age. I remember this one. Age and age 26. Can declare like that. So these are three main ways to declare a variable in Go programming language. So this is the first way, second way, this is the third way. Declare a variable. Okay. So I would like to print the variables that we have created. So we can start by let me do here. So mm declared but not used. So I can come here and fmt. The package will be imported automatically. Print. Remember we said that print should be a capital. So print ln line. Then you pass a value of this format value of string, comma, then I can put string. Okay, so I can duplicate this one so that I can do alt shift. Now value of n is n. Value of m is 20. Is m. Value of mn is mn. Okay. So as well, I can declare the variables of val name string here as well. user int 26. Okay. Then I can come here and print as well age name age. Then I can duplicate this one to more. Then I do Alt Shift. Then I duplicate the age or email. Age. I can click here and hold that in the Alt. Then I can change this one age like that. Also, knowing shortcut when programming saves your time as well. So when I come to this one, I can copy this one too. And now print these lines here and a country. Let's say country. Age. Okay. But this one I can change to, because I have age variable here. This one I can change to something else like a phone, number. So I can do like that. Then I can do phone. Change my country here because I'm from Kenya. It's my country. So these are 3 ways to declare variable in Go programming language. And if you have any other way to declare it, please share, or I leave the link, the repository link for this tutorial. You can create a PR, or then you can create an issue on my GitHub. Then you can share any other way to declare variable. Or yeah. So with this, now I can run my file to check if it can print all these variables that I have assigned. So the first way is var string nm. I can also add another variable here, mn float. This means that I expect a decimal places in mn. Maybe nm can be a different number like 20.5, like that. Mn can be a different number like that, 15.5, because this one is a float. We see when I try to add a decimal place here, the Go is complaining because the type that I've given to this nm is an int. But when I add a decimal place in a float, it is not complaining. That tells me that I'm following the Golang syntax. So when it comes to C programming language, you have to add commas in every function or in every line of the code that you have completed or you have written. Okay, but in Golang we don't do that. So I set it to variable demo. Then I do go. Let me make this one bigger. Go run. Okay, so the value of n is 15. var string hello world mn 15.5. Value of name is Mike. Email is mike@gmail. Age is 26. Country is Kenya. Phone number is this one. So that one, this is a way that you can declare variables in Go. But the best and which I normally love to use is the short form. But remember, you cannot use the short form outside this function. This is a func main. When I try to remove these declared variable and I put them here, the Golang will start complaining. Okay, so expected declaration found country. So you can't use the short form of declaring variable outside the function. Okay, but when it comes to this the other way of declaring variables, I can remove this one and put it here, and the Golang will not complain. You can see. So it depends on how you want to use your variables in Go programming language. So I have talked about how to comment line, how to the comment is the same way as you do the comment to other to JavaScript. Use // then the line is commented. So let us cover about arithmetic in Go programming language. So before we continue, I want to push this code that we have created. Let's do git add git commit let's say learning variables. Then I can git push. Okay. Git push origin, git push. Okay. So this one is going to do push. Yeah. So our code is pushed to the our repo. So in the the second part I want to cover is arithmetic in Go programming language. So arithmetic is operational or subtraction, multiplication, and division. And it's simple. The way you do to JavaScript or Python, you declare a variable first. Then after declaring a variable, you assign that variable. Then now you can start doing your arithmetic by assigning a new variable to the variables that you have created. Okay, I come here and create a new file, a folder, call it as demo. Then inside this file, I can create main.go. Okay, and then I can create this one. Here. Then I can make this one bigger. So as we start, remember that we said that we start by package main. Okay, and then we write our function like func main like that. So in the previous lesson I've taught you how to declare a variable. So I'll start by saying var a b, those values are int. Okay, so I can say a is equal to 10 and b is equal to 20. Any value can work. Okay, and then I can come here now and I use short form of declaring a variable. So I can say c colon equal to a plus b. A plus b. A plus b. Okay. So a plus b is 30. So you can print this one fmt dot capital P print. We have been using print ln. So I will talk about the formatted string, but in the next in the next episode of the tutorial. So there's a print f, print s, print f, s print. Those are the formatted string in the Go programming language. So we like to start with printf. Okay, then in our printf, I can look for the formatted string format. Use decimal, then d. So d here means decimal integer. Okay, so I'm targeting the d plus d, the next decimal integer, okay, is equal to c. Now then I start underline like that. So our first integer is a, the second integer is b, and the third integer is c. So in our missing comma in the adding, there should be a comma here. So fm, printf, this d means for a decimal integer. Okay, I can do a comment here. D means decimal integer. Okay, is it like that? For my typo, integer. Yeah. So it means decimal integer. So when you print this one, you expect to get in our form in our console, it will be a is 10, b is 20, is equal to 30. Okay, so I have to go back to file, then I cd to arithmetic demo, like that. Then I run go, not run but go run, like that. So you can see in our console here we have 10, we have 10 plus 20 is equal to 30. So this one is achieved because of this d target a, the next d target b, the third d target c. So you can go like this and do for subtraction. You can copy this one, then I say like I declare a new variable here. I can say d, so d is equal to b minus a. Okay, then I can come here and change this one to b. B, then a, then d. Okay, so when you print this one, we expect b 20 minus 10 is equal to 10. Okay, hold on. So this one should be minus, sorry for that. So 20 minus 10 is equal to 10. So you can go ahead and create for multiplication, division, but remember for division you can get a decimal point, so you have to pass those numbers with a float. Okay, let me show you. Let me copy this one and print it here. I can see E, and I can now pass this one float. That too. Then I can this one. divide by float at 2 like that. So that means P divide by A is equal to E. Okay, you can go ahead as well and do for negative F print format T as arg from typo. We are getting this one should be a float. We expect a float. I can see to 1 decimal F. Okay, so the code is not now complaining because in division we expect a decimal number. Let's say that I change this one to 9 like that. So that one will be 20 divided by 9. So we expect our answer to be into 1 decimal place. I can also do 2 decimal places. I can also go ahead and do for multiplication, where you declare F, then you say A times B, then you print it. I leave for you to do that so that you can practice. So let us print this one in our, let me clear so that clear, then I can run go. Yeah, so the first one is addition, the second one is subtraction, the third one is division. So in division you can see I have said is equal to 0.2f formatted string. I want the answer to be into 2 decimal, but I can as well do a 3 decimal. Let me show you the effect of f. Then I can run this one, go run. You can see now my answer is in 3 decimal. You can as well put, maybe you want to answer in 4 decimal places, 1 decimal places. Okay, so that one is for arithmetic in Go programming language. So my question is, what is the difference between arithmetic and math operations? Because we are going now to cover math operations. So math functions or math operations, we expect to import a package known as math. So I'll start by creating a math demo folder. Oh, before we go there, let me commit this one to val demo. Or hit I create a new branch. I can say git checkout. That will be a branch known as demo. Then I can git add. Then I can git commit. The message is arithmetic. Add the demo. Then I can push. Then I can copy this one. Okay. Yeah. So our branch is committed. So I can come in and now create another branch folder. I can call it math demo. Then I can come not folder but a file and go. Okay. remember we have to start with package.main. Package main dot okay, sorry for saying package.main, is package main. Then our function func main, we declare our variables using the short form of it. Remember we have 3 ways to declare a variable, so I can say a equal to 2.9, okay, and then b 3.6 or 2.6. So we can now start calculating our C here. So our C is something to do with the math. Remember we need a math function in this code to run. So we have imported, I've shown you how to import FMT. So the similar way, the same way that we imported the FMT, the same way that we are going to import the math package. So I can do math, and then when I click enter, so the import of math is imported automatically. So there's a package, there's a extensions that you have to install for the Golang that will help you import your packages automatically. Let's say power, we want to power our A or our B, our A to how many, to let me say squared. Let us square our A. So FMT dot print. For this one we are going now to use print F. Then I can pass and say the value of C is formatting string dot 2 or 3 F, then new line. Okay, so I can pass in here like this. Then I am supposed to put a comma here so that we will stop complaining. So see math power to this one, so I can do for the B as well. So for this one I can copy this one, come here and change this one to D, and change this one to B, and put this one is D. Okay. As well I can go and do for E what form of it. I can do math.sin. Sin, is it sin or sin? Sin A. Okay, and for this one I expect as well to get a form. Then I can console our this E in this format. E. Okay, so I can do math course as well. I can copy this one and do math course. Pass this one as F. F like that. So this is our math operations. So we need to print this one. So I can just go and So remember, I'm not in the right, so I have to go back. CD, go back. Then I can CD to then I can run main. So the value of C is 8 point. The value of C, so I should check this one. Clear my console. So I forgot to remove C. This one is C. The value of D, the value of E, the value of F, like that. So I can do Golang will go. The value of C is 8 point into 3 decimal, and this one is 3 decimal. So that this is how you can use math operation or math in Go programming language. So first you import, or you can, I've told you that there's a extension that you can install that will help you to import the packages automatically. Yeah, so I think we have covered the best part of math in Go programming language. So let us proceed to increment and decrement. So when you hear about decrement or increment, what is decrement and increment? Decrement is adding, increment is adding, decrement is, in other words, I can say subtracting from the main variable.
Continue to decrement and increment, I would like to tell you that Go programming language is a statically compiled language, and Go is a general purpose programming language. Go has a built-in testing tool that can help you to test your code, and Go is object-oriented programming language in its own way. We shall cover that one when it comes to struct, where you type something to struct of this one. So we can see how the inheritance of structs works. So that's what I mean when it comes to object-oriented in Go programming language. So I would like us to continue from the increment and decrement. So what is increment and what is decrement? And Go has a special syntax for increment and decrement. That one is positive and negative. So positive is plus plus, negative is minus minus. So I would like to start by creating a folder known as increment decrement. Then we can create a main Go file in that folder. Okay. So I create a folder. I can call it incdec. Then I come here and create a folder main.go. Okay. So main.go. Remember that we have to start with the package. So it's package main. Okay. Then we can declare a function with func main. Okay. Then we can now start doing our increment and decrement in this part. So we can start by declaring variable as we have done in the previous lesson. So the first variable we declare is val. Val is equal to a. Let's say a. Val a. And then we can now increment. So in FMT, my FMT should be imported dot print f. Then now we can do our a. Okay, then we want to start from, and then we don't have to go out of, then we can pass our a. So what do you expect when we run this program? We expect to get that a is equal to 4, but now we want to increment our a. So to increment our a, we can now change our a. We can manipulate our a is equal to a plus 2. Okay, and in this matter we can now check now our new a. So fmt printf our a plus 2 equals decimal integer. Then you can check now our a is at this position. So when you come here to the terminal and we cd to our ink deck like that, then we run go build. Okay, you can clear this one. Go run main, let go. So we expect our first a is equal to 4. So a plus 2 is equal to 6. So a has been incremented. So let us check for the decrement. As well, you can do a plus plus for this matter. You can say a plus plus, then fmt dot printf. Remember, printf should be a capital P. Then we can say a plus plus is equal the integer, and I forgot to say this one should start in a new line, and also this one should be in a new line. Okay, then now you can pass our a plus plus, our a. So in this case, our, then this one, there should be a comma. So our a plus plus should also be decremented. Let us check. Let us run this one. Let me clear the terminal first. So our a is equal to 4. A has been decremented from 6. Then the 6 has been decremented to 7. Okay, so we can do similar way for the decrement. I can do like this for the decrement now. For the decrement, I can copy this one, then I can change the signs. Okay, so for the a, I can decrement it by 2, and this one I can decrement 2 to get 1. You can change here as well, and I can change this one as well. Okay, then I can clear terminal. Then let me comment this one out because we don't want the increment. We want to check for the decrement. So for the decrement here, and I have to run run main.go. Okay, yeah. So our a initially a is this one. So we have decremented a minus 2. We have 2. Then we have continued to decrement 2 by 1. Then we get 1. Okay. So that's how the decrement and increment in Go programming language works. And I would like also to cover about getting input from keyboard, where you can get input and now play around the code and print out the result. So to get the input, I would like to tell you about the unique code that we use. There's a scanf, like the way we have been writing printf, and in this case we need the input of a value, like maybe radius, length. So to do this, let us create a folder by the name of any let's call it our folder input demo. Then in that input demo, we can create our main.go file. So before we continue, I can create a branch for this one. Git checkout -b. Then I can call it this one increment _inc_dev, and I can git status to check the code that I'm going to push. And this okay. Then let me clear here. Let me do git add and git commit. Dev demo and git push. Then you can copy this one and push to okay. Then you clear the terminal. Then I git status let me clear. Okay, so let us continue for the input demo. So for the input demo, and I'll have to create a folder input demo like that. Then I create main.go main.go. We start by package what package main. You can see package main here. We declare a function func main, and then we can now start writing our code. So we want to get the radius of a circle. So fmt, we start by printing line, print ln, then we can say circle area calculations, area of a circle, and then you can proceed to fmt print. So this one you did, the user enter radius value, and at this point now we can declare a variable var radius, and val radius, it is a float, a type of a float. Remember that we talked about the types. We have int, strings. How to declare a variable? We have to tell the Go which type of variable are you declaring. So you have told the Go that our variable will be float 64. It will be having decimal places. So we have to print it to input it now. So we have to use scanf, and scanf it will target the the f, not capital, okay, and this one, it will be a pointer to our radius that we have declared. So to declare a pointer, we do the radius ampersand radius or the value. Okay, so I talk about the pointers in the next episode, where I'll teach you more about how you can use pointers in Go programming language, how you can change values using the pointers, and so on. So for this one, we want now to declare our area. So you can say our area is equal to math by, you have to import that package, and then we have to times by our radius. So okay, mathematically the area of our radius is equal to pi r squared. So we have to power our radius into 2. So is math dot power. Remember in our math demo where you showed about math sine, math power, math cos. Okay, so we have to pass math radius to power of 2. Okay, so we can now print our fmt print ln, and we can do circle of a radius is, we can do our radius into 2 decimal places, is equal to the area, the circle area, or with radius, the circle area with radius that one 0.2. We want our answer into 2.2 f. Remember to put a percentage here. That one is a Go programming syntax. Okay, so the circle area we have with radius, this is equal to this. Okay, so this one should target a new line. After you have to start a new line, and to start a new line you use /n. So you have to target radius. Good, and the next parameter is area. Okay. Or what have I written here? So area is undefined. Oh, remember that the way we define variables in Go without using the val keyword, we have to put semicolons like that. Okay. So let us cd, let's go back and then cd to our input demo. Then we can do go run name that go. fmtln. This one should be fmtf because we have f f f. So let me clear variable, clear terminal, then run again there. So enter our radius, we can say in our 2.5, or okay, let me do 2.0. So we know 2.0 is 2.0 raised to is 4 times 22/7. Then after that we can click enter to get the circle area with radius of 2 is 12.57. You can also check the radius of any circle that you want. You can input any value there to check the radius. So in this lesson you have learned how to do input in Go programming language. So you use the scanf keyword to scan the pointer, and you can also, okay, let me show you what is pointer. I can try to fmt print ln, and then I can print our radius. Okay, 2.0. Our radius is 2, but let us now print our radius like that. This one is radius like that. So you can see that there is a pointer. These values, they are stored in this value here. So we shall cover more about the pointers in Go programming language and how you can use pointers to manipulate or to change the values in Go programming language. Good people, what's up? What's up? So in our previous tutorial, we covered more about input demo, and we talked about pointers as well in that demo. And today you are going to cover more about comparison operators. So when I talk about operators in programming language, it is normal like in other programming language that you have covered. This is equal, equals, not equal, greater than, less than, greater or equal, or less than or equal to. So without wasting uh, much explanation, or let me dive into practical part so that you can see what I mean by a comparison operator. So I'll start by creating a folder, then I create a file, main.go. So this time I do it in a terminal. I've been doing it through this folder, then file, but I want to show you using the terminal. So using the terminal, I do mk make directory. I want to make directory comp. Then I can call this one operator. Then after that I can say touch main. Before I say touch, I have to cd to the folder that I've created, comp operator. Then after that I can do touch main.go like that. Then I can create a branch, git checkout dash main dash b. That one you can call it a comparison. Okay, so we are in the branch of comparison, so that I can clear this one. Then I can come here to my comp operator. I can check main.go. We usually start with package main, main, then our function func main. Then we can now start using our. So before we continue, I want to maybe to comment some operators in our file here. Let me comment these are the operators that we are going to use, like that. And this one is not equal. Let me put it here. Can see comma here. Let me put comma here. Then say not equal. So this one is equal. These are the operators. And equal, not equal, greater, less than, equal to, equal, or greater than. So to use these operators, we have to declare a variable. Remember how you declare variable in our previous videos. So val, and to declare multiple, I can say a 20, then I can copy 32 or 38. Okay, so when it comes to printing our variables, we want now to print our to show the operators. So we can use fmt. Remember fmt, when I click enter, the fmt should be important here automatically. Good. So then I can print line. Remember our p should be capital. ln. Then I can now pass a is greater than b. Then I can copy this line. Let me remove this. Let me minimize this terminal. I can copy this line by doing alt shift down. Okay, so that I can say for more like a minus or a less than b equal, and this one I can say which one are not equal, not equal should start with exclamation like that. What else? Equal, less or equal, can change this one, or equal, like that. So a is greater than b, we expect false. A is less, this one should be less, we expect true. and then a no, this one should be like this. I don't know why the Go is complaining. A why the Go is complaining? Oh, we have to start with this sign like that. So is greater or equal, we expect false. A is not equal to B, we expect true. A is less, we expect true. Okay, so by doing this, we can run now our program doing like go. I run main go. Hope it goes well, and we see the result in our terminal. Initially, I was supposed to do go build so that the go can build itself. So it will take time, and as it takes time to build, let us check on other items. That one is comparison operator. We have a logical operator. And why is it taking a lot of time to compile? Let me check. I think I have to go build first. Go and then that go. I can use different terminal. Let me use PowerShell for this case. Let me use PowerShell for this case. I have to cd to com operator. Then I to go run main.go. Yeah, so this one is showing the result, and our, as you can see, false, true, false, true, true. So our operators in Go programming work like that. So let us proceed to logic operators, and in the logic operators as well, I'll have to create another. Oh, even this one it came to run. So thank you. So let me clear this one, and as I clear this one, I can now maybe git add, git push. No. I have to commit first. Git commit comparison operators. Okay, then I can do git push. This matter now. Git push. Then I can take this one, and so that I can push to the right upstream. Okay, so as we push, okay, I leave the triple link in my video description there. So let me clear this one, and go ahead and create another. I have now to cd back, then I create a directory. I can call it logic operator. Like that. Then I can do touch main.go. Okay. I can clear my terminal. Then after that, I can now cd to our directory. Where is it? We are logic here. Then let me check. Oh, I have created main.go in the root file, so it is not supposed to be there. Let me delete it from there. Then before I create the file, I have to cd to logic cd logic operator. Okay, cd logic operator. Okay, then I can clear. After clearing, I can do like this. I can now touch main.go. Then I'll have to create a main.go file in there. Where is the file logic operator? Main.go is there. So in this main.go, I have to start with package main. Okay. Then function main. Then I can do I can show you the operators that I'm talking about. These are the operators. In Go logic. Okay, so these one are the logic operators. Let me remove this one here and take this one here. So this one is these are two studying lines, the or, the ampersand is two ampersand is and exclamation mark is not equal, and this one if this one and this one is true, if this one and this one, you see. So it is obvious that we use a val to declare variables, and I have to declare two variables, a and b. A is equal to 10, b is equal to 15. Okay, then I can now do fmt 10 dot p, it should be capital, print line. Then I can do a greater than b, and ampersand and another command, or another condition that I want here is a is greater than b, then a not equal to b. A is greater than b, which is false, and a is not equal to b, which is false. So we expect false to print this line. Let me, okay, because as you can see, a is not greater and a is not equal to b. So I can copy this line here, then I can duplicate it more times Alt Shift. Okay, so then I can check for other 2 or 3. Let me do these two. Then I can say A is less, or I can say A is equal to B, and then A is greater than B. What do you think? You can comment your answer for this one, and let me do for this one. You can say the answer for A is equal to B and A is greater than B. Is it true or false? Okay, leave your answer below in my comment section. So this one, we have this unique part for checking. I can say not equal. Then I can check A greater or equal to B. Okay, so what do you expect here? I see this function A is equal to B, which is not true. This one, will it be true or false according to you? These are the it is saying that A is greater or equal to B, which is false. Then you are telling it to be not equal. So you are saying this one is not equal. So this one should be this one should be true. So let us do go run main.go. Like that. So as we wait for our terminal to, we see we have false, and true. So if you said here is false, you got it right. Keep it up. Okay. So this is how you solve a logic part in Go programming language. And we have to check more. You have to read more documentation about comparison logic in any other programming language, so that you can understand more about the logic and comparison. So when you come to decision, this is where you use if or else condition. I know you have heard of if, else condition, switch cases, case 1, case 2, and in this tutorial we shall cover more about uh, cases, if conditions, else conditions, and how they are used in Go programming language. Make sure you subscribe and share my video. So starting with a decision in a Go programming language, we talked about if and else condition and switch cases, and I would like to dive into the practical part of it. So if condition, if you're coming from JavaScript programming language, you know that if as a bracket, but here in Go programming we don't use brackets. So let me show you if condition in Go programming language. So I'll start by creating, I go back to CD, ICD2, this one full course, then I create a directory, mkd, it's not mkdr, and then the name of the directory, I can say conditions. Conditions is okay, it's not quotations but conditions. Then you can see to conditions. After seeding to conditions, I can do attach main.go. and main.go. Then we can check our conditions, check the file main.go is there. Then we can write our code here. So if something, let me say if something or if condition, let me put here if condition, if condition do something, I have to screen, that way I'm looking here and my keyboard is here. So do something, then I can do else, do another job, So if else condition, so if condition this one, if condition one do something, else do another job. So in Go programming language, I would like to take you through the condition in Go programming language. So as usual, we start by package main, and package main func is func main. Okay, func main. Then in our func main should be func main like that. So in our func main, we have to declare variable val a b 8, then a should be equal to something else to do with 3. Okay, so we can now do our if condition in this part. So if a is greater than b, remember we talked about comparison operator. These the two starting strokes means or a minus b is less than a, So in this scenario, you can check out you can console log, but in Go programming say fmt import that package dot capital P print ln. So printing ln, we check the condition of a greater than b. If a is greater than b or a minus b is less than a, we print that one. Or, so that means two of the conditions, if one condition is true, we expect to get the 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 fmt print, like we expect to get one condition is true or one condition is true or both conditions are true, or both conditions are true. Else, you can see now, else fmt not print ln, you can say now that means that condition A and condition B, they are not true, so it will jump to else. So no condition was right, no condition was true, that way. So when I clear our terminal, and after clearing our terminal, you can go run main.go. Okay, I have so many if and else's in your code, but using a switch case can help you to have a better reading code. So my program is taking a lot of time to compile. Okay, yeah. So one condition is true or both conditions are true. Okay, so this one should be R. So as we check here, so that means A is greater than B, which is false. But now the other condition is true. Good. So let us proceed to switch cases. So for the switch cases, still I will create another go. Let me do touch a switch go switch.go. And then I can remove this one. Then I come here to conditions because I have created switch.go. Then you can now use switch cases. So the syntax for switch in Go programming is start by switch and switch option. Then we can do case option 1, colon, and then you can do case 2, option 2, okay. So in switch option 1 you can say do something, switch switch option 2 you can say as well do something, option 2, okay, do something option 2. So in this is it solving or something, do something in this part and comment this line like that. So we can start on the switch like this. Remember, we start always by package main. So package main, and our package main, we have to now to write func main. Why am I having so func main like that? We declare our variables. So we can start by select. Now we declare our option 1. This is a variable is equal to 10. Okay, so in this we can now write our switch option, then now we can do case. Let me do case 5 like that, fmt dot ln. We have to check selected, or you can say option 5. I think at this level I have to duplicate this one. For how many times? I can do 3 times. So I will hold alt shift down. So I can do this one K6, this one K6, K7, case 8, case 9, and I can jump this one and do case 10. And I don't know why the funcmain redeclared these funcmain redeclared these func redeclared these. Okay, let me, then you can have a default point. So default is default fmt print ln, then I check option or others. Let me say others, like that. So why funcmain redeclared in this? Why the boys complaining? It's saying that we have two funcmain, and I can comment this code like that. Then I come here and check why we have funcmain main redeclared in this. Oh, so the error has gone away. Okay. With that said, let us now do run or go main go run. Is not main now, it's switch dot go. It's switch dot go. Remember that we are not using main, you're using the switch. Let us check. So as we wait for the program to run, let us check on our other part. The iteration. I would like also to cover iteration in the next video. The iteration is for loops and while loops, and I'll talk. There is a unique part of Golang where we don't have while loop in Golang. We have a while for loop without a condition. It is known as while loop as well. Okay, so as you can see, option no, this one should be option 5, the one should be option 6, this one should be option 7, this one should be option 8, this one should be option 10. Okay, so we can clear this one, and I can run this one again. Go switch main.go. So it is 10. So it has chosen option 10 because our selected or our option is 10. So our option is equal to this. So our option is our option is equal to this, and if our option is not among the cases here, we expect our system to tell us that the code is fmt print line others in that matter. Okay, so remember to subscribe and share and comment for the next video about the for loops and while loops in Golang programming language. Chapters we have covered a lot. We have covered arithmetic, comparison, conditions, hello world, increment and decrement, input, demo, logic operators, math demo, variables, and let us continue with iteration. So iteration, it is where when you have repetitive activities, that where the iterations comes in, where you have to iterate a bunch of arrays, a bunch of numbers. Maybe you are searching for a number in that array, or you are searching for a certain name in that array. Like you iterate or you loop and find maybe the index 1, index 2, index 3. Okay, so in Go programming language, we have for loop, and we don't have the while loop because uh, from my own perspective, I see the the while loop in Go programming as a for loop without a condition. Okay, while something is doing while this code meet this condition, it continues to run. So it is a like for loop without a condition. So what is a while loop? While loop is a for loop without a condition. Okay, so let us start by iteration for loop. So I start by creating a folder, then main.go in that folder. Okay, so this is it. Make directory, then make directory, the name of the directory should be iteration. Then after iteration, I can cd to iteration. Then I can do touch main.go. In that process, I can check the iteration. I can start by package main. Okay, func main, then func main. So let me show you an example of iteration. Iteration. Here we have for, these are for loop now. Then we have initial point. Then we have condition. These are condition point. After condition point, we go to increment or decrement. So inc stroke dec. Okay. Then maybe you can say now fmt or you console there, or it is like consoling in Golang. So let us do it practically so that you can so that it can make sense. Okay, so in this part I'll start by for loop. Okay, I'll start by declaring a variable var I can say this one is int. Then I can say for I is equal to 0. Our I start from 0. Then you can say I, if I is less than 10, what do you want? We want to increment our I. So that one is I plus plus. Okay. Then you can now say fmt dot print ln. Then we can say I want to get our value I. So we can clear this one. and we can check. Let me check if in that folder we have main.go. Clear the terminal again. Then we can do go and main.go. Okay. So audio, as you can see, so 0 up to 9 because it is less than 10. So what if you put equal here, because I showed you the comparison operator. So equal means that 10 value will be printed here. Okay, so that one is for loop in using the general for loop. Let us now cover the for loop using the range keyword. Okay, so using the range keyword, let me comment this one out and this one out as well, or I can leave it. uh, so we start by declaring our variables. Let us say numbers. So this, remember the way we declared variables, we say there are three ways you can declare variables: multiple, as in a single manner, or you can use colon equals. Okay, so this one should be strings, or okay, numbers. Should be uh, array of ints. Okay, like that. Then I can pass 10, 1, 4, 6, let's say 6, 7, 9, 20, and so forth. Okay, so for us to iterate through this array, we need to, for I, let us say for index value. Okay, index value range. So range is a keyword in Go. So range numbers. Okay, so if you range numbers for value, and okay, so we need to fmt print line, like that. So we target the index comma value. Okay, so this our array is not sorted. We can sort our array as well. You can say slices, import slices, fmt import slices, and then you can say dot sort, capital S, Golang syntax, and then we can pass our numbers. Is it going to work? Yes. Yes, it is going to work. So slices dot sort numbers. So let us clear this one. Before you do slices dot sort, let us see what will happen without sorting. So go. Let me also remove the. Let me comment this one out so that you can have a clear definition of it. And yeah, this one. Okay, numbers. So it will be go run main.go. Okay, the go is complaining that we are importing slices, but I have not used it. Let me comment this one out as well, and then go again before we sort our and check. Let us see what we expect. We expect index and value. So 10 is index 1, 1 is index 2, 2 or 4 is index 3. Yeah. So 0 index 1, 1 is 0, 10 is index 0, like that, like that. So let us say that we don't want to print our index. So let us uncomment this one, and maybe this one. We can now sort our array before we iterate it. So in this matter, we don't want to get our index. We are only interested with value. Okay, so to ignore the index, because the goal is complaining, but you have declared index value and you have not defined it, so we use dash. I can say dash, like that. So this one means that we have ignored the index value. We are only interested with the value inside. Okay, we're only interested with the value inside this int. So I clear my terminal. After clearing my terminal, I can do go run main.go, like that, and we now expect to get the sorted array. So the sort numbers. If the numbers are sorted, we expect to get 1 as the first index. You can see 1, 4. So the array has been sorted. Okay, and thanks to the Go programming language, because it is easier to use, simple to implement. Okay, so let us move to what else I've not covered when it comes to okay, let us now move to break and continue, where now the code might check the break if it is iterating, and maybe you want to say if our I is equal to this, we want the code to stop from that point. Okay, so for this matter, I'll have to clear my terminal again, comment this one. Okay, and come here and now do for the break and continue. So for the break and continue, okay, before I check for the break and continue, remember I told you about the while loop in Go programming language, and I told you that Go does not provide while syntax like C family programming language, but it is a while loop without a condition. So let us see iteration with while. Iteration with while loop, like that. So our package main is there, our func main is there. So we have to declare an int variable. So val, or you can use I. Either way it will work. Just for the practice, you can say our I is equal to 0. So our initial. So our for I less than 10. We want to fmt not print ln, like that. We want to check our I. Okay, so you can check the while loop. It is a for loop without a condition. As you can check our for loop here, we have a condition. The condition is I is less or equal to 10. So in this matter, we don't have a condition here. So this is a while loop in Go programming language. So for this code to run, maybe when you go run like this, we will have an infinite looping. So we have to check our increment. So I plus plus, like that. So we can come here to Go as usual, go run main.go, main.go, like that. So that means that I is equal to 0. For I less than 10, fmt print I. So I plus plus or I minus minus. Okay. Okay. We have another. who is complaining about this one. We are not using slices now. We are not sorting. Let me clear terminal. Then we run go main.go. Is it run go or go run? Go run main.go, like that. So as we wait, we will see that I is less than 10. FMT print I. So this while loop, the iteration of while loop is where you don't have a condition. The while loop is while it is true, the code will continue running. So while I is less than 10, the execution will continue. Okay. So this is the while loop in Go programming language. Thank you. So let us proceed to the break and continue. Break and continue. And this is simple. Is we just use the for loop, and we implement the if and else in our for loop now, where we check if I is equal to a number, we break it from there. We say that that code should break. The code now should not continue running. And continue means that if the code is running and we check if I is equal to something, we tell that code to continue. Okay, maybe it has reached to a point and we want to check something. If that number is there, let that code continue running as well. Maybe you are searching for something else in that matter. Okay, so in this we'll start by I'll have to I is equal to, remember, semicolon equals 0. Okay, then I implement the for loop for I is equal to 0, like that. I is equal to 0, and then we check now the condition. We want to say that if I is less than 10, we increment or decrement, or let's say I plus plus, like this. So I plus plus, then we can now check the condition. So if our I is equal to, these are the strict equals. Remember, in JavaScript we have 1 equal, 2 equals, 3 equals. So in Go programming still we have the strict comparison. So if I is equal to 2 or 3, what do you expect? We break this code from here. Okay, we break. So this code will stop running at point 3. Okay, so at point 3 our code will break and stop running. So let me make this terminal smaller here. So let us check our FMT print ln then you can check for I. So let us do as well for the we expecting semicolon there. So let us check as well for the continue now. Let us check for the continue. So I'll have to copy this one and implement it here. Copy. Then I can change this one to, what else? I can change this one to another variable like j. Can change this one to j. J. Can change this one to j. Can change this one to j, like that. So our loop, I can declare j here. So I can say j equal to 5. Remember, semicolon. Then matter, we can see that our I is less than 5. So here we can say continue. You can change this one now to continue. So continue 5. So if this j, so our j should be equal to j, okay, in that matter. Yeah, so our j should not be equal to 0. No, it should not be equal to 0. It should be equal to, let us increment 5 here and remove this one here. Will it work like that? Yeah. Okay, let me clear this one. And let us check the, let us put this one fmt print continue, continue. Then this one is for fmt break. So I j is equal to 5, and it will continue from there. If j is equal to, and let us check now. So that means this one should be j, not that one. Let us check our code if it is okay. So if j is equal to 5, it will jump 5 and continue printing 6. But if this one is I is equal to 3, it will stop there and show 0, 1, 2, 3. Okay. So in this matter, I have to do go run main.go. This matter, yeah. So let me make my terminal bigger. So you can check this code. It continues. Why is it continue 6? Am I written continue? Yeah, 1, 2, 3. 1, 2. If it is equal to 3, it stops. Then it continues from there. 7, 6, 8, 9. Okay. So that's how the break and continue works in Go programming language. And I would like to tell you that we have finished chapter 2 in Go programming language. So the next chapter you are going for array, slices, and maps. That one is chapter 3 now. We shall cover more about the arrays, slices, maps, how to iterate maps, how to slice arrays, how to do, how to declare slices in Go programming language, and how to work with them. Please make sure that you subscribe and share my video. Thank you. What is array? What is slices? What is maps in Golang programming language? So I would like us to cover 3 topics in one video. That one is maps, arrays, and slices. So we would like to start with a definition of array. So what is array? Array is a numbered sequence of elements of a single type with a fixed length. So example, remember, we start our package, our code by package main, not package slices, but package name, then func main, and then we can now display our array here. So val, I can say x, val x is equal to val x is array of how many items? I can say 5. Yeah, like that. Then I have to say the type of it, int. Okay, remember in Golang we normally say it is in left English or left to right, where you say you declare a variable, then you say the type. But in C programming language, you say the type, then you declare the variable. Int variable. In Golang we say variable int. So let us proceed to this one. So var int. So this array has 5 items. Okay, and we want to do now iteration. Let us do iteration here. So to do iteration, we have to do either normal for loop or iteration. Okay, so to do iteration, we have to declare variables. Val, we have declared it there. So x1 0, we assign that one to 98. Then I can click Alt Shift, then I copy to how many times? 0, 1, 2, 3, 4. So 1, 2, 3, 4, 5. 5 items on it. So 1, 2, 3, then 4. Then now I can come here and change these items. I can say 98, I can say 88%, I can say 42, I can say 50, I can say 100, like that. Okay, so we need to to iterate this one. So what is normal for loop? So for I is equal to 0. So for I 0, comma, then we say I less than total items there is 5, not 6. Okay, then we increment our I. Okay, so we want to assign the total. We want to check the total of the array, the total of the items there. So let us say val total is a float 64. Can say float 64. Then here I can say now the total for this one is plus total is plus equal is it plus equal, yeah. Then we pass the x, then the I. Okay, so if it is like that, and we want now to check our to check the console, that one is fmt dot print ln, then we check we say total divide by length x, but this one is not. So fmt is undefined, so we have to import it here. Import fmt, not fmrt, is fmt. Okay, so this one is going to give us the length of the total length, then the total divided by the length of this array, but still we can say divide by 5, like that, and it should be go time main.go. Okay, so that one is going to give us the average total of the output in our mhm. So invalid. Okay, this one should be equal to 0. Total invalid operation total is money. Okay, what should be there now? This one program, it will not invalid total. Okay, let me check how we can write this program in another way so that it can run without errors. So we expecting that. So okay, to remove this error, you can say float 64. Then we pass the length x. I see there's that error there. So to remove that error, I can still use a different iteration here. So for I, so for index, but you don't want index here, so we can ignore it. We ignore like that. Then value range is range regex, like that. Then I can remove this one. Then as well I remove this one. Then I can pass total here now. So total is equal to plus equal value. Invalid total operation is managed. Why? There is error. Oh, I'm supposed to change this one. Oh, I declared the values of the iteration to int, then this one for float. So this one should be float and the other one should be float. Okay, that's why I love Golang. So go run main.go. Yeah, it is running 74. So there is another way we can manipulate these values here. That one is x. We can say x equal to, we can say, can pass the values float 64. Then now we pass the values. You can say 98, 56, 50, 90, 53. Okay, what is one expected to be in an element like this one? Okay, so yeah, so you can see that I have a comma in the last item in the array. That one is 83 comma. If I write another number 76, it should be having a comma there. Okay, but now remember our items are 5, so you can change this one to 6 so that Golang will not complain. So when you clear this one, the terminal, and you run go run main.go. .5 good. It is now working. So that is how you can work with arrays, and this is a short syntax for declaring array. Short syntax. Syntax like that for declaring array. Then there is the iteration and total value. Okay, yeah, so this one is for array, and we can now comment this one out, and then comment this one out as well. Then we can now proceed to slices. Okay, so slices in array, I can see slices is a segment of an array, and like array, slices are indexable and have a length. Array, I've said that array slices are indexable and have a length. Unlike arrays, this length is allowed to change. Here's an example. You don't now put like the way you have done val x, then you declare array 5 like that. So here we don't do that. You can say float number. Okay, and the only difference between this and array is the missing length between the brackets. In this case, x has been created with length of 0. You can see there's a 0 length here. So if you want to create a slice, you should use a built-in make function like this. So this is a short form. You can comment this one short form, and as we write the short form of this one, we can do x colon, then we say make function, then we declare our slice, then we say float 64, like that. Then we can now pass 5. Okay, is it written float or float? Float, not float. Yeah, so these create slices that are associated with underlying float 64 array of length 5. Slices are always associated with some arrays, and although they can never be longer than the array, they can be smaller. The make function also allow a third parameter. So what they mean by that parameter, we can do comma, then we pass 10, like that. Okay, so 10 represents the capacity of underlying array, which is the slice option 2. So another way to create slices is to use low and high expression. So low and high expression is this one. Low and high expression. We can say x colon equal to array. Then we create now slices 0 to a certain. Now you can take the say array here, then 0 to 5. So that means that we want all numbers from 0, 1, 2, 3, 4. We will not include 5 in the array. Okay, so slices, we can now do slices comes with built-in function to assist them. That one is append and copy, and I would like to show you how to use append and copy in Golang in slices. So in this one I can declare a first slice, the first slice. Then I can say the first slice, remember it is a short form of declaring a variable. Then I can say this one float 64, or let me use int. Okay, I can say 1, 2, 3, and this one you can say slice 2, slice 1 equal to slice 1 is equal to, we can now append slice 1 or slice, then we append to 4 and 5 and 6, like that. Okay, so slice 1 is declared, but okay, no problem. So in our fmt dot p capital print ln, this one we want to print our slices 1. Okay, and we can as well print slice 1, slice, like that. I can comment this one, I can comment this one, I can comment this one, like that. Then if our program is not complaining, let us clear the terminal. Then we can run our go run, and we can see that we will see that these slices int 1, 2, 3, it is here. Then we have appended the slice 1. The slice 1 is equal to append slice this slice to 4, 5, 6. So we take 1, 2, 3, we append them to 4, 5, 6. So it will be 1, 2, 3, 4, 5, 6, as you can see here. So this one is slice 1, this one, the first one is slice, the other one is slice 1. Okay, so let us do the example of copy. This one is for append. I can comment this one. This one is for append, copy. Okay, so for copy we can do let me copy this one, and then uncomment, uncomment this one, uncomment, and I can change now this one to copy. This one append to nuke function. Okay, and this one is a slice. Let's see what is happening here. This one is a slice, and this slice contains, it is a type of int. Remember, this one is array of this one. This one is now a slice, and this slice accept only 2 items. Okay, so you can say copy, copy build function, copy slice 1, slice 1, we accept the data from slice, and this slice has how many? 3. So after running this program, what do you expect? The slice 2 has 1, the slice 1 has 1 2 3, and slice 2 has 1 2. So the content of slice 1 are copied to slice 2, but since slice 2 has no room for element, only the first 2 elements of the slice 1 copied. You understand? So when you copy this one, slice, so the slice, okay, let me name this one slice 1, then this one slice 2. Then we copy the element of slice 2 from slice 1. So this one is slice 2, slice 1, this one is slice 2. Okay, so in our int here, the slice 1 has 3 elements, the slice 2 only accept 2 elements. Okay, so when we print this one out, go run main.go, let's see what you expect. We expect 1 2 only. We expect to get, for the slice 1 we'll get 1 2 3, but for slice 2 we expect to get 1 2, because our slice accept only 2 elements. Okay, yeah, so that one is for the slices. Make sure you subscribe and share my all. So let us proceed to maps. So what are the maps? So maps in Golang, I can say map is an ordered collection of key value pairs, also known as associative array, a hash table or dictionary. Map used to look up a value by its associated key. Here is an example. Let us do example in Golang, and let us see how. Let me check the good example for this one, where we can have the mapping, the good mapping of it. And I would like to use this one. So maps, you can see elements. So these elements, we assign them to map. So it is make function, then map. Okay, so you can see that map, it has a type and type. So our first type, we can say it is string, and the other type should be a int or string. Okay, so if you have declared element like that, now we can say elements like that. We pass the string. The string is, you can say h. So h maybe starts for string house, like that. Let me copy this one several times. No, it should be like this. It is not copying. Let me copy this one. Shift. It is not copying. Okay. Let me copy it manually. Like that. Remove that one. So this one is for, you can say C. The other one is for, you can say D. D for dog. You can say what else, M. So this one is for cat. This one is for dog. Maybe not dog. Is it dog or dog? Oh my god, dog. This one M for mouse. Moose. Okay, so the iteration for maps is very unique. Like, let us now check the data in the maps. So if name, comma, okay, then this one is equal column equal to elements, is not elements. Elements, we want to check which element. H. If this element H is there, if this element H is there, okay, we expect to print fmt or print ln name, comma, okay. So I can clear this one. Let me clear terminal. Then you can do go run name.go. And we expect to see house is there, true. Okay, so if name, okay, element, you want to the name of that one, then okay is a boolean. Boolean is a true or false. Let's assume that we put the k instead of h. Now we put the k, we expect no name and false. Okay, Yeah, we expect no item to be printed because there is no name like that, and it is not okay. Thank you for watching. See you in the next topic. That one is functions in Golang. Thank you for watching. Hello Gophers. So in this tutorial we shall cover about functions, and I have covered a lot of topic in my previous videos. If you have not watched my videos, please go back in my channel and check my previous video on the part of hello world, arrays, slices, variables, how to declare variables, and it will help you more to understand, because we are going now to the more critical part of Golang programming language. So in this tutorial we shall cover functions, and I shall start with what is a function. When Okay, how can you define a function in an interview question? Let's assume this is an interview question. And what is a function? So a function is a block of statements uh, that can be used repeatedly in a program. Okay. It is a block of statement that can be used repeatedly in a program. So assuming that you have a program, and you want to uh, you want to write a function that it can be called several times in your program. So a function can be repeated. You can call it anywhere in your program. Okay, let us do it now practically. So I'll start by creating a folder, then a file in that folder. So mkdir is a command line to create a folder. I can call this folder functions, like that. Then I cd to functions. Then now I can touch main.go. Okay, so when I go to my function, then I open the main.go, I can see I have the file and the folder has been created. So we start by package main, then func. We declare our function in this matter. So in general way of declaring a function in Golang programming language, you usually use function name. I think I have been declaring functions in the previous tutorials. So is func, then the name of the function. Okay, so let us do a simple way to understand it. It is, I can say func, then the function name, uh, the function name, then I can say return data type. What do you want to return with this function? Like that. Then I can say return, maybe I can call it name, and then name is type of string, like that. Then when I call this name, I can say return mic. So this one, it will not work here because okay, this one was for simple function, the way the functions or to show you the format of a function. So let us dive into the real function for the uh, function. So remember func, our func is main. I target this one. Then I can create another function func. How can I call this one? Foo, like that. Then in this function I can do fmt. Is it fmt? Yeah, fmt. I import it there. Print ln. Then this one can say who was called. Who was called. Then I can come here and call foo function. Okay. So this is a simple function. When I run this function, I expect to see who was called. So I can clear my terminal. It's not create but clear. After clearing my terminal, I can run go run main.go. I think this is okay because now this function, it is now initialized to the main function. So when I run this code in this package, we expect to see who was called. Okay, so this one is a simple function. Simple function. Okay, so let us proceed to functions with parameters. And I don't know why the go is not showing in my code. I think there is a problem with that. I have to check. The terminal is so slow. Let me see the two functions. Let me clear the terminal. cd2 functions. Am I in the functions? Yes. Then I can do go run main.go. And I think when I go back to this one, maybe you can see result. Yeah, who was called this one. So I can, yeah, even this one as who was called. So this one was a simple Golang parameter. So for us to push this code to our, let us create a branch, git checkout -b, can call these functions. Then I can go git add then git commit message add simple function, add simple function. Then I can do git push, check the push. Expect to run there. Okay, I can now clear the terminal like that. And I can now proceed to functions with parameter. And this one, let me comment this one out. And I remove the foo. Okay, in general, let me comment this one out. This one. And comment this one out. Okay. Then we come to this another part where I can do another now function with parameters. Functions with parameters. With parameters. Okay. So in these functions with parameters, we are going to calculate area of a circle. Okay. So this is simple. You can start with func circle area. Area. Then I can do r. Then this r is for the type of r. We can do float 64 because r can be a decimal. So that way we say float 64. Then our area we want, so the in general area is equal to pi times r squared. Okay, and you remember we covered math comparisons in our previous tutorial where we had math power, math sign, math cos, math subtractions, additions. So in this one, remember how we declare variables in Go, similar to equals. Then we do math. So you have to import the package of math. So you have to click there so that you can import the package there up. Then dot pi, capital Pi. Okay. Then this one times math dot power POW. Then we pass what? Our r raised to power 2. That will we write math radius to r squared in using the Golang. So in this one we can now do fmt dot print format print print dot print f, and then you can say circle area. So circle area r, circle area with r with r equal to with radius. This one should be v. Okay, with radius, this one should be radius, and instead of this one we can do 0.2f. Okay, like that, because the radius can be a float number with point decimals. Is point is 0.2f still. Okay, so when you come here we pass the r comma area. Okay, the area, then we put a comma here like that. So we have to uncomment this one, the function there up. Then we remove foo because we are no longer uncomment foo. Then you can go back to this one and pass our circle function. Circle. Then we pass 2.4, 2.5 is our radius. So we expect when we run this one, so to, okay, you can do your math calculation in your laptop or in your calculator, and let's see if you arrive to the same answer with the code that we have written. So go run main.go. Okay, so this our code. It will run and show us the radius of 2.5. What is the area of that circle with the radius 2.5? Okay, so you can see here the circle area with radius 2.5 is I have to remove, it is not point, is like that, should be like that. Let me clear here again, clear. Let me run our code again. Go run main.go. So the circle with radius 2.50, remember our 2f is 0.2f is 19.63. Good. So let us proceed with the code with more parameters in this matter. So I can come here again and I declare another variable. It is good if you could put this one slash n. So I can come here and another function. Let me make this terminal bigger or smaller. So I can say calculate or func calculate. Calculate what? We want to pass 3 parameters in this matter: a, b, c, like that, and these one are all float. 64. Then what do you expect on these? We expect the result. We cannot the result of, remember to declare a variable in short way. That one is a times b times c. So that one is the result. So to print this one, fmt dot print f, we can do print f. That one is, we can say a okay, we can say a is equal to point 2 f 1 decimal or 2 decimal places, 2 f b is equal to 2 decimal places as well, 0.2 f. Then I can copy this one and duplicate for the rest, and the rest is c, not many. Then we copy just one like that. Then I do c. Then I come here and start new line. Then I can check on, remember comma, then I pass a b c and result. Okay, so we need also to declare result, and result is equal to result is equal to point is equal to modulus 5.2f still, like that. So a is equal to this value, b this value, c this value, and result for this one, a times b times c. So we can come here in our main function and pass this calc is calculate, then we pass our a is equal to 2, 5.5, 2, 5.5, and 2.3. So these arguments are enough for our code because it is a, remember it is a, b, and c, and the result is this one. So I clear the terminal, then I do go run main, let go, like that. Then in our terminal, we expect now to see the total of a is equal to this one, b is equal to this one, c is equal to this one, and result is equal to this one. So our a is equal to 2, b is equal to 5.5, c is equal to 2.3, and the result of this one is 25.30. You can confirm with your calculator 2, 5.5, 2.3, and see if these are the results. So this one is for parameters or many parameters in a function. So let us now cover the function with a returning value. Okay, so for this matter, I proceed to this. I create another function. So function. So this one function is for JavaScript that it is okay. Func advanced calc. Let me say advanced calculate. Okay, so in this advanced calculate, this is where when you're using a return value, it's either now you are returning a specific type of data. Okay, it's either you're returning hint, you are returning float, you are returning strings, bytes, and so forth. So in this matter, we have our a again, b, c. Okay, and these types and these data is float 64. Then we want to return our data as float 64. Okay, so in this matter, we use a return keyword. This one is a return keyword. So we want to return our results. So our result are not defined. So to declare our result is result, and our result is a still times b times c. Okay, so we can copy this one, the similar code that we have here, and pass it here. Is it complaining that return result. Okay, let me run this code and see what are we getting. Go run main.go. We expect to see the result, no, but this program will not run because we have not called this function in our main function. So we have to do advanced then we pass our values. That one is 3, 5, 6.6. Then I clear the terminal, and with that I can do go run .main. Okay. Okay, let us proceed to the next. I shall cover more on that one. So this one is return single, or yeah. So let us go to multiple returning. And on the multiple returning is just the way we have written this function. So I'll have to copy this one, put it there. Then I can change this one to let's say copy this one. I can change this one to compute. Then we have ABC float. I can do another value here. That one is name. Then the type of name is string. Then I can return multiple types. And if you're returning a multiple types, you use you close them in brackets. So that one is float 64. Still I can return another float 64. I can as well return string now, because remember we have a string now case. So I can call this one result1. Then I can copy this one. So is alt shift, or is it not copy? Alt shift, like that. Let me remove this one because I'm not interested in result1, result2, result3. So in this one we can put plus sign. Then this one is plus sign as well, and I can proceed to this one. Then we can do this one is equal to result1 plus result2, and I can call again a new name, and I can declare this one, and the new name we can say fmt dot s print f. So I would like to talk more about the formatted string. So sprintf, this one it will return the new name as a string. Okay, So this one, it will not be, it will be printed in our console, but the new name it will be, because S means save. So save the format of the printf. Okay. So this one, so S value. Remember, I have to enclose this one. Okay. S value is equal to point to F, but we have to put what? Modulus percentage. Okay. Comma name result 3, like that. So in our returning here, we need to return 3 parameters. That one is result 1, result 2, and new name. Okay. So because the new name contains the result 3, so it will be FMT. So the name is Michael is equal to result 3. So the result 3 is equal to result 1 plus result 2. So this one is result 1. Then I return result 2, and then I in the last one is new name. Okay. Yeah. So this is how you return, and I need a comma here because Golang is complaining. So when you come here and call our compute, can come here again and do compute. So compute, now we call our A. I can say 1.4 comma 2.5 or 5.5 comma 6.3 comma then string. I can say I call. So the Golang will not complain because all parameters have been passed. Okay. So that is how uh, you return parameters in multiple. So assume now you have unlimited with multiple parameters. Let's say you want to, you may want to, and you have unlimited parameters on function. It is possible to implement it in Go. Yeah, we can use spread parameters. For those who are coming from JavaScript, but they understand when I call spread parameters. So spread parameters is this one. You can say simple func add, then I can say numbers, numbers, and these numbers are types of int. So we can spread our numbers int. Okay, like that. Then we, what are we returning? We expect to be int. Then in this matter, we can now declare our result to our result 0. Remember now you want to look through these values in numbers. So for we don't want index, comma, then we want value. I can say v range a number, then you call them numbers because they are many. Okay, so this one is equal to result, how am I not writing the result well? Result equal to plus equal the total of v. Okay, So in our case here, we can now come here and return now the new result now. Result like that. So this function has unlimited parameters. So this one, the three dots means we spread the data across the function. So this one is for multiple or unlimited. Let me call it unlimited. Okay. So with that one, I've shown you how to implement unlimited parameters in Golang. So let us cover now the closure function. Before then, we can proceed now to recursion. And recursion, it is assignment for you. If you remember Fibonacci, how to write Fibonacci, if n is equal to 0, return 0. If n is equal to 1, return 1. Then now you can return Fibonacci n minus 1 plus n minus 2. Okay. So for the recursion, I'll have to review it for you. So with that said, let us check on the closure functions. So closures. So what is closure? Closure, this is where you call a function inside a function. Yeah, we implement a function inside another function. Okay, for example, closure, and in this closure, let me call a function func closure. Let me closure func. Think that one will be okay. In this closure func, we expect a name. The name should be a type of string. Okay. Then now we implement a closure function inside the function. So this function, you can say who, and in this function now you can say func who. We pass our parameters, that one a comma b. These functions are type of int, and if they are type of int, we expect now to say what do you want to do with the parameters there. Okay, they should not be spacing the way I've expect. So results, result a times b, or a plus b in that matter. Then now I can do fmt. Why am I not treating it the way? Fmt dot print ln, or printf. What do you expect to say? You can say who function is equal to decimal integer. This one is for d. If I write that like that one is decimal integer, then I can do result. Then you pass this one as a times. Okay. So for this matter, I can as well write another function inside the function. Then I can change this function and call this function Joe. Then this function expects to return int parameters. So in this matter, we can do return result. Okay. So I can remove this one, and I can change this one to plus a, can return it like that. Joe declared but not called. Okay, so to call these our functions in this you can do fmt printf printf, then we expect to closure closure func. Remember the name of our function was called. Okay, closure func was called, and this closure we can say closure name, the name of our closure, new line, comma, and a pass name. The name should be passed here. Then in this matter I can call the whole function within the who. Can see the who function is 2 and 3, and then I can come here and declare our show so far show. Then I can pass parameters as well. You can see 2 3 then 4 5, simple. Then I can come here and call this function func. Is it func or fmt print f. Then I can say what, val from Joe. Then I can pass the is equal to decimal integer d, comma, that one is the format of it. Then I can pass the val. Okay, so in our other functions I can do like this. This one return result. I'm not interested in this one, and this one. So let me come and run this function here, closure func. In our top here, closure func, then I can pass name. Which name should I pass? I can say Elon. Then I can clear the terminal. Then I can do so run main dot go. Yep, good. So closure func Elon was called. Who is happening here? Let me solve this one. Then you go then you do this one to start in a new line, then this one new line, then I can run the terminal again to see. Yeah, clear. And we expect to see the who function is 6. Then the other one is, so yeah, so the closure func elon was called who is equal to this one, and val from Joe is equal to 24. So that one is how the closure functions works in Golang. So the next chapter we shall cover here is recursion. Recursion. And recursion, I want to remind you about Fibonacci. Remember Fino? Is it Fibonacci? Yeah, I think I've written it correctly. Fibonacci numbers. If you remember how to solve Fibonacci numbers in Fibonacci or Fibonacci, that way. Yeah, Fibonacci, where you return if n is equal to 0, return 0. If n is equal to 1, return 1. The default one is return Fibonacci n minus 1 plus n minus 2. Those are the Fibonacci numbers, the sequence of Fibonacci. So I'd like to say thank you for watching the tutorial of functions in Golang. And if you have anything that you want to add in our file, I leave a link below for GitHub link. And if you have any other thing that you can add, please comment in our comment section, and I would like to see what you can add in our code or in our tutorial so that people can learn from you as well. And make sure that you subscribe and like and comment and share. Thank you. Language. And before I proceed, I remember in the last tutorial I left a question about Fibonacci numbers, and I hope you solved the question. And if you have not solved the question, we will solve it before we proceed to pointers. And I would like to start by defining Fibonacci numbers. So what is the real definition of Fibonacci numbers? So Fibonacci is a series of numbers where each number is the sum of the two preceding numbers. Okay, example, let me show you on the screen. I start by package main. Okay, not make but main. uh, and then here I can do func or function main, like that. So Fibonacci, we have said that is a series of numbers where each number is a sum of the two preceding numbers. So imagine that you have 0 and 1. Those are the two numbers. So that means 0 plus 1, that one will give us 2. Okay. And in our case here, what are the two preceding numbers is 1 and 2. So 1 and 2, the sum of 1 and 2 will give us 3. So what the preceding number here is 2 plus 3. That one will give us 5. 5, the next number is 8, the next number is 13, the next number is 21, the next, and so forth and so forth. So this is a Fibonacci series. Okay, so the sum of the two preceding numbers, so 0 plus 1, 1 plus 2 is 3, 3 plus 5 is 8, 8 plus 13 is equal to 21. So let us see how we can do this one using a Golang programming language. So in our case here, we will create a function, func Fibonacci, and then in this function, we have to pass one parameter, that one is n int, and then we return int in our case. So we shall check if n is equal to 0, return 0. Okay, and this function expected this one, move this one there and put it here. So else if n is equal to 1, we need to return 1. Okay, and if so, we need now to check the return of Fibonacci. That one is return you can now return Fibonacci n minus 1 plus Fibonacci n minus 2. Okay, so this is our function, and we need to call this function here. Let us assume that our n is equal to 10. Okay, now fmt dot print f, we check the format of, let's say, Fibonacci, like that. You can pass a decimal integer of n is equal to still decimal integer d. Then you can start a new line, and here we can pass our n, comma, and then you can pass our Fibonacci function. Then we pass n. Okay, so our n is 10, and our Fibonacci function is here. So return Fibonacci n minus 1 and Fibonacci plus n minus 2. So let us see the result of this function. Okay, so go run main.go. So Fibonacci 10 is 55. Okay, let us assume that we are solving Fibonacci of a large number. So in this case, we have to refactor this code here. We have to refactor this one, and for let assume that we want to check Fibonacci of 100n. Okay, so in this case we can check, we can use for loop. That one is, we can now come up with two variables here. Remember, in Golang you can declare two variables in one line. So b is equal ab is equal to 0 and 1, like that. So for I is equal to 2, I less or equal to n, then we increment our I, then we return a and b, where you assume a is equal to b and b is equal to a plus b. Okay, so in this case here we can do return b. Uh, it is a problem here. Expected it is return, not return. Okay, so in our case here, we are returning a is equal to b, and I think I can ignore this one and put comma here. It will not work. Let me check. So we need to check this problem and declared a and not used. So you are doing, okay. Oh, I have seen the problem where it is. We are doing shadowing in the loop, and this it will make our loop to stop. And for this matter, we have to remove the colon before the uh, declaring the variable. So like that. So let us check if we put our n is equal to 100 and not 10 now. I don't know if it is going to run on my computer. Let us check if this Finobachi is going to work in my computer. So Finobachi, yeah, it worked. So this is how you can solve Finobachi in large numbers. Maybe you can try even 1,000. This is a code that remember that our first code it was a simple return, but we have now refactored it by using a for loop, and we have seen that it is working. Let us try for 1,000. it is working, and it is so fast, so fast. Okay, so before I proceed to pointers and uh, on how to use pointers in Golang, if you have any question about these Fibonacci, please leave comment in my section and I'll answer your question there. Okay, so I need to commit this one. I can say git add git commit add Fibonacci and git push. Okay, and for this, so let us proceed with pointers in Golang, and we shall cover the purpose of pointers and how they are used to manipulate data in Golang. So what is a pointer? A pointer is a programming language object whose value refer directly or point to another value stored elsewhere in the computer memory using its address. Okay, so when you define okay, example, you can define x as an int, then we can call x value by calling x, we declare x is equal to 1. To know the memory address of x, we can use ampersand x to test or to know the memory address of this project of this variable. Okay, so I'll start by creating a simple folder. mkdir make directory pointer okay, I have to cd to, let me go back, mkdir pointer cd pointer touch me.go. Okay, let me clear my terminal. And to this point, I can go to my pointer me.go. Then I can create package name. Func name. And at this point, we can now start declaring our variable. Short form of declaring a variable, you can say x is equal to 1. Okay, I can say fmt dot print again x, can fmt dot print ln ampersand of x. So for this code to run, we have to import our fmt there, and it should be fmt. Okay, so in this matter you can do f not f but go and me.go. Go run me.go. Yeah, you can see now we have printed 1 and the address of 1. Okay, so that one this one print the value, print value, this one print the address of the value, address value, address value. Okay, so in this matter we can now continue to our next to use the pointers in now Golang. Now in this part we can now declare a pointer, declare pointer. Okay, and there are two ways of declaring a pointer, and one way is using let me say var num int. Okay, so var num is pointer to is to memory of x. Okay, like that. And then there's still another way to declare a pointer, and that one is I can now declare a variable is equal to new int. Okay, so I can say var is equal to ampersand x still. Okay, so in this matter I can now print out the values of this one, the values of, let me copy this one. So val print ln num pointer of x, print num, it will be now print the value of x. This one will print the address, then pointer of val, it will be this one will print the value of x, this one will print the address of x. Let us check. Let me clear. Good, 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 good. So one is there. So let me explain what is happening here in our terminal. As you can check, we have 1 and the address of 1. Okay, and this address of 1 pointer num, let us go to pointer num. Pointer num is point to 1, and then address of num. So the asterisk symbol that you see there, it is differencing the reference value. It is the references value of uh, address. That means we can use this dereference value to manipulate our data or to manipulate our variable. The same thing that happens with this one. The asterisk value before the val means that we are dereferencing uh, the address of num, okay, or the address of x. Sorry. So fmt print ln var. This one will print the address. Sure. So in our case here, when you come here and maybe we try to say asterisk val is equal to 2. Okay. Then you go back and now clear terminal and try to print this one again. This one, okay, this one. Go and me.go. Go run me.go. Yeah. So this one shows that our value, the pointer num, is now equal to 2. Pointer num is equal to 2 and val num is equal to 2. So that means we have now changed the value of x because of this pointer. The pointer changes the address of x. Okay, so that is how we show the pointers in Golang, and we can still cover deep in a deeper ways that shows how we can use the pointers in Golang. And these are in other ways where you can use the pointers in Golang. I would like to use a very simple example that will show us how the pointers in Golang can be used to manipulate the data. Okay, so I do git checkout dash p, and I say pointer, and I do git push. It will push the 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 branch that you have created. Then I do git add git push, or rather git commit pointers. Then I do git push again, then I clear. Okay, so with this send, I can now comment out this. Okay, I can, okay, instead of commenting out this code, I can still work on something here. I can continue working on this, or still I can comment this one out. Let me comment it out. Then I can comment this main, and let me show you working with pointers. Okay, so working with pointers here, let me make this terminal smaller. So we shall continue with, remember we have our function there, so it will be val let me say creature is our variable string. Our string is equal to, I can say, shark. Okay, in this matter I can go ahead and go at val pointer. Remember this is a pointer, we have to say that one, string is equal to ampersand creature. Okay, hope up to there that you know what we are doing, you can understand what we are doing. And then from this point I can now do fmt dot print ln, print ln, then I can now pass creature. You can say pointer comma, then I can pass the pointer value. Remember the reason why I have used this asterisk before this variable is to dereference, dereferencing the value of the creature. I'm now trying to get the address that is stored in that creature so that I can print it out. Okay, so this pointer, it will print out shark. Okay, so in this matter, if I go ahead and check for fmt, if I go ahead and check for fmt, instead of doing this I can alt shift down, it is called alt shift down, and then I can say for creature, after doing creature I can remove this one and do creature like that. So these two fmt, these will print, all of them will print shark. This one will print shark, and this one will print shark as well. Okay, because the asterisk point here shows that we are now targeting the variable itself, we are not now targeting the pointer. Okay, unless we remove this asterisk, it will now print the address of shark, but with the asterisk there we are going to get the shark. Okay, so this pointer, you can use this pointer to change the value of shark to something else. Okay, so we can say pointer, then we say that this pointer can be equal to something else like snake, or no, I can say, yeah, snake instead of shark. Now let us call this one snake, and then now we can repeat printing these ones and check how it has changed. Okay, it will not now become, it will now going to print snake, and the creature will also change to snake. Okay, So up to this point, I hope that you understand how now you have targeted and changed the uh, pointers in Golang. And for us to be sure on this one as well, we can now try to print the pointer and creature. So this one will create the address like that. And this address is let me comment that one. So this one will print out the address of shark. The creature will be shark. This one will be shark because now we're using asterisk before the pointer. Then we are dereferencing our pointer in other terms. Then the pointer snake. Now we have changed our variable to snake. So that means that our pointer will be snake here. And then this one will be snake as well. Okay. So let us now run our terminal to check on this. So it is go run main.go, and let us check the output for this one to see if we are going to get the address creature shark. Okay, shark. Yeah, so you can see pointer this one, then the creature shark, then the pointer shark, shark, snake, snake. You can see. So the pointer, the dereferencing value, it is helping us to manipulate the pointers in Golang. Okay. So in the next topic, we shall cover more about functions, pointer receivers, and how we can use pointers receiving the data from the variables and how we can manipulate them. Thank you. In these methods, so in struct, as you can see in my screen, the way we declare struct in Golang, it is the similar way we declare struct in C++ or C language. Okay, so in our case here, we have type struct name. The type struct name can be any name that you want to put there, can be your name, company's name, school name. Then struct is a type of that name. Okay, then the field of the struct. So we can do it practically so that you can understand what I'm saying. In here, we have to declare our field. After declaring your field, then we have to write variables or the parameters that we want to be implemented in that field. Okay, so this is a good example. Let me take it. So in our type struct, we can now pass how many parameters? 3 or 4 parameters. Okay, so here in this field we can have id. Id is a type of int. Okay, we can have name, type of string. We can have country, type of string, and let me spell the country well. It's not country. And then we have we can say created time. It was created time. So time, it will be have to be imported time dot time, like that. Okay, so in this struct we have now declared our struct. Okay, but this code is not in the main function. We have not implemented the usual way or the syntax way of Golang. So in our case here, we have to write, I have to remove this one. Then we can do package main func, not fin, func, function, main. Then now we can declare a variable, declare our struct here. Okay, type struct this and this. Now in our function here, we can now declare our variables. So to declare our variables, we have to declare. So in this case, we have to declare our variables like that. Why am I not writing variables? Okay, variables. Okay, so to declare variables in or to instantiate the struct, there are two methods to do that. Okay, and I would like to show you the two methods. And before I show you two methods, please make sure that you subscribe and share my video. So the first method is this one. We have val, and this val we have this struct name here. So I can decide to call this struct name employee. Let me assume this one is employee struct. Okay, like that. And for this one struct, let me capitalize this one so that it will be okay when I. So for this to declare struct or to instantiate the struct here, we have to write val emp employee. Okay, so the type of emp or the variable emp is type of struct employee, and the employee is a struct up there. Okay, this is one way. The other way, we can do the way the new way of pointers. This can be done like this. I can say new emp like that, and then I can pass new, then I pass the name of the struct inside there. Then this one should be employee. Are we okay? So these are two ways to declare struct in Golang. So after you have done this, now we can set our values. We can go ahead and set our values. Set values. Then to set values, we have to check. We have now to check the values that we have called, or the value that we have instantiated with our struct. Okay, so the value that we have instantiated with our struct is emp and the new emp. So we can say emp dot id is 1. Okay, I can say 1. Then I can copy this one down. I can do alt shift copy, or alt shift then the down arrow. So this one should be name, the other one should be country, okay. Then the last one was created. Okay, so this one should be name. I can do name. What is happening here? Name. Then this one still I can do let me do country Kenya. Then this one should be created time now, so it should be time. Then this one will be imported time dot now. This one is a function like that. So emp id, this emp is instantiated to this struct up here, and these are the, we have now set them values. Okay, so to set the values for the next method of declaration, we can do the similar way. We can now take this one, new emp dot id, okay, dot id, then we pass 1, or we pass now 2, okay, then I can do alt shift down arrow, then I can copy name here, I can do country, I can go ahead and created. Okay, so this one for created is similar way, time dot now, then I can remove the last one because we don't have another item in our struct or another field. Then in this field I can say Nigeria, this one should be a string, remember. Then I can come here and do name, our name should be David, then id of 2. Okay, so we have now set values for our new emp and emp, and I have shown you how to declare variables and set variables from the struct. First we create a struct, we declare a struct, then we set values. Okay, so to display these values from the struct, we have to do like this. It will be fmt should not be I think, okay, it should be fmt and fmt should be imported. Okay, it has been imported automatically. So fmt dot print ln, then we can now pass emp id, emp dot id. Okay, so I can do alt shift down arrow, I can copy this one, then in this here I can do name, in this one here I can do country. Okay, and this one is created. Okay, so with that said, I can copy this one and copy it here now, and remove this one and do I need to separate them like that. Then for this one it is new emp. Okay, so to copy to write this one, I can do alt, then right click, alt, sorry, it is alt, right click, then I can do new emp. Okay, like that. And therefore to call this to run this or to display our struct now, we have to do, let me do this one like this so that I can separate for emp and new emp. It is simple, go run main.go, simple. And this one will now display our data or our struct in the way they have been declared or they have been set there. Okay, so if you have any question about struct, if you have any question about Golang, Please leave your comment below. I will answer your question. And if you want to be mentored or you want to start in Golang and you don't know how to start with it, please feel free to reach out to me. I'm going to help you. Okay. So as you can see here, name is, why is it name? Okay, I wrote name. Okay, name Kenya. Then the time is, as you can see on my screen, is 11:37 as well. Here 11:36. Then it is EAT time. So the time that we created this tract was simple. Simple. Make sure you subscribe, share my video, and if you can do a search tutorial like I do, please feel free to connect. Then, as you can see on my screen, we shall cover methods in Golang. And what is methods in Golang? So the methods in Golang uh, is okay. Golang support methods. Go methods are similar to Go functions with one difference, and the methods contains a receiver argument in it. With the help of a receiver argument, the method can access the properties of the receiver. Okay, so the receiver can be type of struct or non-struct type, and when you create a method in your code, the receiver and the receiver type must be present in the same package, and you are not allowed to create a method in which receiver type is already defined in other packages. That one is including inbuilt type like int, string, uh, etc. So I would like to take you through the methods, and we shall be creating 4 methods in our screen here. And as you can see on my screen, I have created the methods folder. Then I have created main.go. Okay, so we shall start there and proceed with our practical part. So in this part, we shall have to declare our struct. Then we declare our struct. And remember the way we declare struct from the previous tutorials. We normally say type, not type, and the type is, I can say, circle, and this circle is a struct. Remember that I have said that in Go methods we can use struct type or non-struct type to declare or to work in with the methods. So with this, I can now pass my parameters here. Circle as radius, let's say 2 parameters. So in this case, I'll have to do xy. Then the xy in my case, they are int, and this one should be closed so that Go can understand that these ones are together. Then we have radius. I can declare radius. Radius can be in any form like 2 point something. And I remember that int is a whole number, but float allows you to work with decimals. Okay, so float 64. Yeah. So in this case, we have declared our struct. This is our struct, the one that you can see here. This is our struct, and I can comment here so that you can struct. So after declaring our struct, we can now come here in our, let me remove uh, the written code there. So we can come here and create now our function, and this function, it will contain a receiver from the struct. Okay, so to do that, I have to use func c. Then this c receives type of circle. Okay, then now this is where we have to create our method. So our first method is display. display like that. And now we can tell our method what we want here. Okay, so in this part we shall pass fmt print f, and we can check for x. We can say that x is equal to decimal integer, and then comma y is equal to decimal integer as well, then r is equal to 0.2f. Remember, 0.2f means that 2 decimal places. Okay, so in this case I'll have to put comma here and pass the parameters x, y, and r. But in this case we have to instantiate the receiver cx, cy, and cr, so that the Golang will stop complaining. So in this case we have written the first func. The c here, you see, it is a receiver. It receives from the struct. Okay, so I'll have to create another function. This is what to display the, let's say, area. This the display here shows the display of the values only. So let us now calculate the area of this circle using the method like area. I pass method. So to do this one, I'll have to remove this one, and now use the word return, the result return keyword. Remember that we covered more about math of comparisons, where you used math power, math pi, and you remember very well that the area of a circle is math, it is pi r squared. Okay, so to do this in Golang, we have the math package, math.py times math.power. Then we check our receiver. Our receiver is C. Then what do you want to power C? The radius of a circle power to 2. Okay. So the Golang is complaining that math is defined, but it is not used. We have to import it. Let me import it automatically like that. So it should be imported there. And then we have to proceed to calculate the circumference of the circle. I have to copy this one and copy it here. Then this one, I change this one to circumference. Circumference. How is circumference written? Circumference. Okay. Then we return, what is the circumference of a circle? It is 2 pi r. Okay. So I have to remove this one. Then I pass 2 times pi times r, c dot r. Okay, so with that, I think now we can display the values, calculate the circle of the our struct here, circle. So to do that, we have to come now to the our main function. So when you come to the main function here, we have now to initialize the values. So I have to declare a new variable, like I can say shape. Remember the short form of declaring variable. Then shape is equal to circle, the struct there now. It should be capital C, circle, capital C. Then in this matter, I pass the parameters now. So the first one was x, the second one was y, and the third one was radius. So I need comma here to separate them. Okay, so in this case we have now initialized our values. Okay, so to call our values I have to do like this. Now this, remember our methods here: display, this is a method, area is a method, circumference is a method. Okay, so to call this one I have to do like this. I have to come in and do shape, because now the circle struct is initialized to shape. So I have to do shape dot display. Then I copy this one, alt shift. It is the Golang is complaining that I'm using I'm not telling it the type that I want to return in this matter. Okay, let us solve that one. Okay, I'll have to solve this one. Too many return value, float 64, float 64. So to solve this one, I can come here and do float 64, and the same way I have to come here and do float 64. Okay, so by doing that, the Golang is now not complete, because the Golang wants to know what type of data that you are returning. Is it a float? Is it a int? But in our case, it should be float because we expect decimal places. Okay, so in this case, we have a shape.display. Then I do alt shift down arrow. Then I check for area, alt shift down arrow, then for circumference. So this one is for area, this one is for this one, circumference. Okay, so by doing that, now we can print our uh, our 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 console to check what is the area and what is the circumference. Okay, so this one I'll have to uh, do. Okay, let me do this one is equal to, let me do it like this. I don't know if it is going to work, but it will work. uh, I can say a representing the area is equal to this one. I cut it and place it there, and circumference as well. I can say C shape equal to this one. Then I can do here D is equal to that one. So by doing that, I can do fmt dot print ln. Is it print ln or print format? Then now I can say area is equal to decimal point 2 f. I want my area into 2 f, or 2 decimal places, like that. Then I can pass a. Then I can duplicate this one, alt shift down arrow, and okay, let us pass our, okay, to display, or let us show the display first. but the display will be shown instead of using the. Let it be like that. Then here I can do C, capital C. Then I can remove this one. Okay. So by doing that, we expect to see the area and the circumference of the, like that. So area is equal to 2f, circumference is equal to 2f, the value of the C, shape dot circumference. Okay. So by running this code, go run main dot go. So by doing this, it will calculate the area of the circle by checking the values of the struct that we initialized in this area here. Here, shape. Let me. Okay, it is okay. Shape, circle, x 10. Radius. The other. Oh my God. Okay, it is showing that x is equal to this one. This one. Area. Okay. I think I need to start in a new line like that, and slash and new line. I think this one will work out, and let us run it again, because you can see x is equal to 10, y is equal to this one, area is equal to 45.36, circumference is equal to this one. So as you can see, there you go, but it is showing the area. It is not showing the area in a new line, but circumference is shown in a new line. Okay, so circumference is this one and the area is this one, by doing with methods. So this circle, this C is a receiver, and it accepts from the struct. Then you do the shape, then you initialize the values, then the shape dot display, a dot shape area, or shape dot area. We can also call the we could, instead of doing a is equal to this one, we could copy this one and put it here instead of a. Okay, so by doing this, I think you have now understood how to use methods in Golang. So let us proceed. Methods, these are the methods with values, but remember in Golang it accepts methods with pointers. How can we now manipulate that? We can change that value of this struct. Maybe the x and y after initialization was 10, 5, and maybe we want to calculate a different value of the different circle in the same code. So this is where now we have to initialize the pointers. So working with the pointers in this matter, we have to create the similar way, but now we accept the pointers. Okay, let me show you. This is a very simple way to work with Golang using the pointers. So I think I'll have to continue with this one. I'll have to do pointers here. Pointers methods. Pointers methods. And as you remember that the pointers method in Golang, maybe I can repeat myself on the pointers where you declare a variable var uh, val val score int, you can see is equal to 10. Okay, and in this matter we can now declare a pointer, and to declare a pointer we can say val p or pt, and this one is a pointer int is equal to score. Okay, val score int 10. So for us to change this value, we can come here and use the pointer like this. Pt is equal to 11. What the expected declaration found. Why is it complaining? Okay, let me check why the problem. So to change this pointer, we have to do pt. Pt is a pointer to score. Okay, let me print this one out first and check. And check out. You can come here to our main package. Let me minimize this one. We can come here into our main package, and we can comment this one out, or you can copy our code here. Then you can do fmt dot print ln. Then I can pass pt. Then I can duplicate this one, alt shift down arrow. Then I can pass score. Okay, so for this matter, let me uncomment this one, or comment the upper part, so that we can work with pointers. So this one, I have to run this. So the score should be 10. Then the pt point to so this one is a pointer. The value is 10. So how can we duplicate this 10 when given this score is equal to 10? So in this matter, I was thinking like we can point to pt then the pt is equal to something else, 12. Okay, so this means that we have now duplicated our pt, our pointer in this matter, and that we expect to get 12. So we'll get 12 and 10 in our console here. Let us check if it will work, because this is how the memory management works in Golang. We check the memory of the variable, then you can duplicate that memory by assigning it to a different variable. but as I can see, it is not working because I'm passing it as a, so I have to put the asterisk sign before the pt. Okay, let me clear again, and after clearing, let us check if our pointers before I came to realize how pointers work in Golang, I was totally confused. I was trying to understand why pointers and how can I use pointers in Golang. Okay, so as you can see here, I have changed this one to the value has been changed to 12 and the pt has been changed to 12. So that means the score, the value in the score has been changed. So what if I print out this one? Let us check the result on this one, pt, then the pointer to it, because now this one is a dereferencing value. Okay, so methods with pointer in Golang, you are allowed to, as you can see, the value has changed to 12 from 10, then the pointer as well as the memory of the variable as well changed. So this one is the memory of the stored variable. Is that not simple? It is. Okay, please make sure that you like and subscribe my channel as we proceed. So let us see how we can work methods with pointer. Okay, how can we create a receiver with a pointer in Golang so that you can manipulate the data? You're allowed to create method in pointers. So in this matter, I think I'll have to remove this one. This one was just showing you how the pointers working. I think I have removed the final. Okay, so in this case, let us assume now we have a type struct of uh, a different thing. Let me come here up and create another struct, and declaring another struct here. I can use type. I can say _. Let me assume that _, and in this _, it has removed this one like that. So we have name of the _, expected to be type of string. We have you can say branch, expected to be string as well, and we have, I can say particles. It is particles here, practicals or particles, particles int. Okay, so in this matter, as you can see, we have the struct of _, and let us now receive, instead of using value or the value receiver, we are now using the pointer receiver here. Okay, so for this matter, to use the pointer receiver, it is the same way that we declared a function here, func c, but now in this case it will be a pointer. So it will be func, it will be a func our receiver _, then this points to _. Okay, so what do you expect in this matter? We create our method show, and what are we showing? We can say we just want to show a branch, and a branch type of string. Okay, then at this point we can say a, remember now a is our pointer, so to assign this value, we can say, or to initialize, a dot branch then we give it to a branch. Okay, a branch. So when you call this show, we can now pass any value to assign it to our function there up. Okay, so remember that in this matter, I have to write this function outside. Sorry for that. I have to remove it here, and let me put here, because I'm not working with closures. So to initialize this function, we have to come invalid operation cannot direct variable type string. Okay, let us solve this one. So for this matter, I can say funcmain, then I am to initialize our values. So remember that the way similar way we initialize shape here, now let us initialize the values there up. So in this matter, we have our outer, we pass parameters. So we had name, and this name was type of string. I can say Michael. I don't know why I love Michael, comma. I can say what was the other parameter? Branch and particles. Okay. So in this case, I can say branch for the string as well. Then you initialize it to what? To Nairobi. Let's assume that this Michael is based in Nairobi. So Michael Nairobi. Okay, that sounds good. So let us print out this one and see what we will get. So in our case here, we have name and branch. So fmt dot print line print ln, then we pass author's name. It is not author's name, author's name, author's name. Start new line to avoid sound. Then we have race dot name. I can copy this alt shift arrow down, then I can branch name, then race dot branch. Okay, so in this scenario, we have declared initialized our outer structure, then we have called it down here. So we want now to use a pointer to change our value. So let us create a pointer. Remember, we initialized that a dot this one is equal to a branch. So let us use a pointer here. So to use a pointer, I have to, let us assume p, which is a value to pointer to race, p pointer to race. Okay, in this matter, now I have to p dot race, instead now of race dot show, p has now become a pointer to this matter, and to change or to dereference the value there, I have to do p dot show, then I pass the value that I want to change it to change the branch. So in this matter, I can say the name of the branch, I can say New York. Okay, so this pointer has changed the value here. So the first one, which will be, let me do this one before so that you can understand. So when I print out this one, and this one is after, then capitalize after, and this one is for after. So by doing this, res name branch and uh, res name branch, and using this pointer here, and this method, the method receiver here, this one, the pointer here that receives a, then a is in form of string show, then we have passed this string here, where is it, p show New York. So we expect the first name Michael Nairobi, then the second printout which will be Michael New York. Okay, so let us clear, and then let us pass and check how the pointers are going to uh, how the pointers are going to manipulate our struct values, our initial values, and the essence of using pointers when declaring variables and how to work with pointers. Okay, so in this matter, I have to say go run main.go. As we wait, we expect now to maybe if our code runs very well, main.go invalid of string operations. Let me check there. We have a problem, and string type variable, which is okay, and we have to check why it is in our code there. Okay, it is receiving a value res.branch, and res.branch after a branch string. So invalid operation. Oh, we have to pass this one like this, because this one is a pointer that is dereferencing. So a, okay, let us check, and it should be invalid operation cannot direct a branch variable. Very good. As you can see now, that author's name Michael, branch name Nairobi, author's name Michael, then the pointer changed it to New York. Okay, so that is how you can work with methods and pointers in Golang. And please make sure that you subscribe my channel as we continue creating more videos on other topics. We shall continue up to a point where you will be creating your own package or your own files to work with Golang. And I would like to have you in this journey. Thank you. String conversion. Welcome to my YouTube channel. And if you have not subscribed to my YouTube channel, please go ahead and make sure that you have subscribed. Your subscription matters to me. Your comment matters to me. Your like matters to me. So in this tutorial, we shall cover more about strings operation in Golang language. And what do you understand when you hear about strings operations? If you have watched my previous tutorials, I covered the basics of strings and the basics of how to declare variables, strings variable, int variables. And for this matter, I would like us to cover more about the strings conversion. Assume that you have been given uh, string and you want to convert it to numeric, or you have been given numeric, you want to convert it to string, and vice versa. Okay, so in this tutorial we shall cover more about strings. So let me do it now the simple way, so that I can make you remember what is string and how to get started, how to get started using how to get into strings. Okay, in this matter, remember the way we start our package. We say package main, package main, and then the syntax of function in Golang, we say func main. Okay, so in this matter, I want to declare a simple string. So val string, I can say the type of the string is the type of the string, and a string is equal to uh, 55 blocks. Welcome to 55 blocks channel. Okay, so in this matter, we have declared the val string, and we have assigned it to welcome to 55 blocks channel. These are my YouTube channel name. So to print out this name, we have to write fmt print ln as usual. Okay, so in this matter, I can do fmt dot print ln, as you can see there, and I have to pass string. Okay, the fmt is not imported. I need to import it automatically so that the Golang can stop complaining. So in this matter, we have printed out our string. So that is how you declare string in a simpler way in Golang. Okay, so if I come here and run this function or this code, we usually do go run main.go. Simple. So for those who are getting started Golang, please go back and make sure that you have watched my previous tutorials as I prepare for this Golang full course. If you have any question about the Golang, please go ahead and ask me. I'll guide you where I can, and it will be okay. So as you can see, we have printed out welcome to 55 blocks channel, and this is how the simple way to declare string. So in this matter, I would like us to move quickly and check on how now we can start converting or make or how can we concatenate strings. Okay, so we can use, as usual, people who are coming from JavaScript, you know how to concatenate a string. We use a plus operator. Okay, and I have covered about the operators, mother comparisons. If you want to know more about the operators and math comparison, please check my previous videos. So in this matter, we have to declare two strings. Let me declare another string here. So I do alt shift down, then I can name this one at string 1, then I can do alt shift down, then I can do this one string 2, then I can say subscribe to 55 blocks, and this one I can assign it to string 1. Okay, so in this matter, we want to concatenate these strings. Okay, so to concatenate these strings, we have to use sprintf. So sprintf, it is a okay, when you do fmt sprintf, it print out the everything as a string. Okay, I'll cover more about the formatting string, how they work, and when to use them. So in this matter, I want to concatenate this one, so I have to change this one to and s there. Then I have to change this one to small p, then I remove ln, then I change this one to f. Okay, so in this matter I want to check my string, and this matter I have to pass two strings, and to do that one I have to use this like that, simple. Okay, then I have to remove this one, I put comma, then I pass string one, the string, the first string, and the second one. Okay, so in this matter my my when I print this one out, it will the result of fmt core not used. Okay, so I have to do, let me declare this one as string 4, and it has not been declared anywhere, so I have to declare it like that. So I have to print this one out, fmt dot print ln. To print ln, then I can now pass, I can say my concatenated con, my con, my concatenated string, concatenated string in this matter. So by doing this concatenated, I think it should be like that. So in this matter I have to pass string 4. Okay, so my concatenated string 4. Okay, let us see what the Golang will print. So we expect to see these and these, the welcome to 55 blocks channel and subscribe to 55 block channel to be concatenated together. Okay, so simple. Then I can run this one, go run main.go. We expect to see the result as welcome to 55 block channel and subscribe to 55. As you can, my concatenated string, welcome to 55 channel, subscribe to 55 channel. So these are two strings have been concatenated. Okay, so we can also as well put something here. You can say welcome to 55 block channel and subscribe to 55 block channel. Then we can put is, then put colons like that, and clear the terminal. After clearing the terminal, we can run our code again to check if it works. And you can see now my concatenated string is welcome to 55 blocks and subscribe to 55 block channel. So is that not simple? It is. That's how we concatenate strings in Golang. So I would like to take you through strings to numeric, how to convert strings to numeric. So strings to numeric. Okay, so strings to numeric in this matter, assume that you are working with variables that have been declared as strings. So example, let me show you. I can say uh, let me say val or string variable or val value is declared to a string of 5. Okay, so alt shift down, then I can do this one as 10, then I change this one to 1. Okay, so in this matter we have two strings, okay, it is a kind of, it is a number, but it is enclosed as a string. Okay, so we need to convert these strings to numeric in this matter. So we have to declare two variables here. So I can say a val error. We have to check for error first, error, and val string 1, or I can say, because we want now to convert the string value to int, because it is a string. Now we want to make it int value, so it is int val, it is type of int. Okay, so in this matter I have to now use standard or string conversion, which helps us to convert strings to numbers. Then I string conversion, then I do pass int. Okay, so to convert string to numeric, you can use string conversion, pass int. For string to int and string to float, you can use string conv pass float. Okay, so but in general we can use string conv dot @atoi. Okay, in my other okay, when I do the other tutorials, I shall cover more about the the pass int, the floats, the atoi, the all those standard libraries that can be used to help you in Golang to understand more and more. So in this matter, I have to check for, I have now to use int val, comma, I check error, and this error, if error is nil, we should expect to get the result. So I have to do string conversion now, conv, like that. It has to be imported there up, and in this matter I have to do pass int, remember, dot pass int, pass int, int, then now I pass the value of the string, that one is string val. Then in this matter I can use, I have to tell the Golang that the base, our string should be base 10, and then it should be the size of 64. So I have to do like that, so that Golang will not complain. Then in this matter now I have to check the error. If error is not equal to nil, what do you expect? Print ln. If the error is equal to nil, or if the error is equal to nil, if there is no error in this matter, I can say print ln, then I can do int value, int value is, then I pass it here, then I do int val. Is that not simple? It is. Okay, so in this matter we have checked the error. If the error is equal to nil, give us the result if there is no error. Else, we can check else, we can say else we want to print the error. We want to know if there is error. Print ln error. Okay. No new variable on left side. What is the Golang saying? Oh, these values have been declared, so you don't have to declare them again. So we cannot use this one because this one is declared here and the error is declared here. Assuming these ones were not declared there, these ones were not there, we can remove them and the Golang will not complain about it. But as long these ones have been declared, we cannot use this short form of declaration. Remember that in Golang. So we have to remove this one to make sure that it works. So in this matter, as you can see, we have now converted our string to uh, to integer. Okay, so let me clear this one, and after clearing, I can now run my Golang to check if I'll get 5 as number. Okay, we have a problem here. This one, the Golang is complaining. I can comment this one. Then that's why I love Golang, because you cannot declare, you cannot commit. It will have to tell you that there is a code, there's a there's a value which is there, and we don't understand why it is there. So as you can see here, the int value is 5. So that means our value has been converted. So in this matter, instead of uh, writing pass int string base of 10 size of 64, there's another way that you can use this syntax, that is what is atoy. Okay, so atoy allows you, atoy is the same as pass int base 10 and 64. So that means we can remove this one. After removing this one, you cannot use string of atoy value of type int as int 64 value is assignment. Okay, that means our Golang is complaining there. It doesn't want us to declare variable in 64 as long we are using atoy, because you're telling now the Golang atoy is same as base 10 to 64. So atoy understands what is the purpose of itself there. Okay, so by doing this, still our code is going to work the same way. Okay, we can clear this one and do go run may.go. Okay, and let's see if we are going still to get my int value is 5. Okay, so you can use pass int, pass float, but atoy is the best way to do it, because it gives you uh, uh not a lot of code, clean code. You can check and understand what is written there. You can, when you see atoy, you understand it is base of 10 and size of 64. That way you can use to convert string to integer. So another question, how can you convert numeric to string? You'd like to know, how can you convert numeric to string? So to convert numeric to string, assume I can say numeric to string, comment that one, and then I do numeric to string. So for us to do numeric to string, we have to declare two variables. I can say num1, I declare it to 1. Okay, and we want now to make this one to string. This is very simple. You don't have to use atoy. So for this one, I have to declare, I can say val string num. I have to create to change this one to num string, then I declare this variable, the type of now this should turn this one to string. So string num is equal to fmt dot s. Remember, in the concatenation how we are using sprintf. So sprintf allows you to print out something as a string. Okay, so this one will be sprintf, like that. The type of it, now you want to check the integer, the decimal integer. It should be decimal integer, comma, then num. Okay, so these are sprintf, it will convert num1, the value of num1 to string. So for us, we have to print this one out. We have to do fmt dot print ln, then we print string num. Remember now, our Golang will stop complaining. And let's say that we don't want to write this one var string num, then we declare it here. We can remove this one there, and then we put semicolon in front of this one. So the Golang will still work. Remember that I have taught the basics of Golang and how to use short form of declaring variables, using val keyword to declare variable, const keyword to declare variables. You can go and check in my tutorial. Okay, so in this matter, we want to check if this code has been converted to a string. So I have to clear my terminal, then I do go run me.go, and we want to check if we are going to get one as a string. So these are as val string num. Yeah, it is working. It has worked. Okay, so in other words, I would like also to tell you that there's something that we call in programming language parser. And before I came to realize what is the meaning of the word parser, it is like disintegrating a string of words into a single word, where you have a lot of words like Kenya, Nairobi, Mombasa, New York, China. So those are the strings of data that are together. But how can we now, let's say that we want to print each word separately, then we sort them out alphabetically. How can we do that in Golang? So this is where now the string parser comes in, where we use a split with delimiter parameter, split where there is a delimiter parameter, where there is semicolon, or where there is a comma. Okay, so in this matter, I'm going to show you practically. This one, I can say string parser, and this in string parser, I have to declare data. I can say this data is a let's say it is a string, is an array of strings. Okay, like that. And then I can pass the first one. I can say it is Kenya, New York. I can pass China. I can pass Nigeria, or Niger. Then I can do which other country? I can do Uganda. Okay, so in this data here we have declared. Remember I showed you how to do for loops in Golang. Okay, so fmt the print ln, then I pass data. Okay, then I have to do now, I have now to declare, like I can say places. These places I want to split them. I can say now string dot split. Okay, like that. I want to split data where there is delimiter, like that. Opera where there is delimiter. Is it okay now? Yeah, declared but not used. So in this matter, we have now to do our for loop. So for, remember we have now split our data. So for I don't want index, but remember how to ignore value that the Golang will understand that you have ignored that value. You're not going to use it. You use dash to ignore value. Then I need to check for place. This one should be, let me do it places. Then I can do place. This place ranges to, we want to loop the places. Okay, and after looping these places, we want now to print out the single place. So it will be fmt print ln, then we pass place. Okay, so in this when our data is not looped, split is not undefined. What does that mean? String type has no field or method split. Okay, let me check why the Golang is complaining. It should be split. Type string has no field or method split. Remember, I have to do like that. So it should be strings, not string. Like this, it should be strings dot split. So the Golang is not complaining now. So in this matter, we have to clear our terminal. It's not clear but clear. Clear. After clearing our terminal, we have now to do go run the simpler way, go run main.go. Invalid operation. Okay, the Golang is complaining here. Let me remove this one and make this one a string by itself like that. Or we have a typo here where you have to remove this one and remove this one and make it there. You're trying to check where there is an error. Cannot use data variable of type string, a string argument. So I have to remove this one as well. I have to remove this one And you can see now the Golang is not complaining because I already declared the variables to strings. So I have to create a variable of create terminal. After creating the terminal, I can do go run me.go, and let us check if you are going to get the data first. Then after getting our data, if this data is now looped, as you can see, Kenya, New York, and Uganda, then we're getting now our data like this: Kenya, New York, China, Nigeria. Then we can still sort. We can still sort our data. I'm not going to do it. I shown you in my previous video how to sort the strings, like how to print the strings, use the sort keyword. Okay, so go back to my tutorials and check, please. Or if you want help, please leave a comment in my video. I come and see how I can help you. Okay, so that's how we use a string parser. And I would like also to cover how to check the string length in Golang. In string length, we use a string length. In string length, we use the ln keyword like that. Then we pass like where is it? I can see, have we declared a string there up? Yeah, string one. You can see string one like that. That is so simple. You check the ln string one, then you can now print out this one. I can declare, you can see, check the length, check ln. Let me make this one small letter. Check ln, and for this matter I can do fmt dot print ln, then I pass check ln like that. And when I clear this terminal and I do fmt, not fmt but go run me.go, in this matter I'm going to get, go run me.go, not main, like that. In this matter I'm going to get the string or the number of variables that are there. As you can see, I have 28. If you count this string, the first one, if you count this one, you get the 28 characters in that line. Okay, so that's how you check the length of a string. And if you have any question about on the length of the string, please leave comment in my video, and I shall come and see what is the problem. So in the next subtopic that I would like us to cover is how to convert strings either to capital letters or to lower cases. That one is small or capital letters. Okay, so I can say to upper, stroke to lower. Okay, so in this case, assume that our first message, I can say lower, or let me start with uppercase. I change this one, and then I say strings dot to upper it is here. Then I pass string like that. Then I can do this one like alt shift down arrow. Then I change this one to lower. then I change this one to lower. Okay, then I can do FMT for this one, then I check upper and lower, then I check for upper and lower. Simple as that. Okay, then I clear the terminal. After clearing the terminal, I can now do go run main.go, and we expect to get this one in the same line, because it will be compiled to upper characters and small characters. So welcome to 55 block channel. This one is capital upper and the next one is lower. Simple as that, how to convert into upper and lower in Golang. Okay, so I would like to say thank you for watching my tutorial. Please make sure that you subscribe and share more as we continue to cover more on the Golang part. The next part, I shall cover more how to read files and how to create files in Golang, how to create your own file using now the Golang language. How can you create the file? So make sure that you subscribe and share, and make sure that you have you ask questions, and I'll be there to answer your questions. Thank you. What is happening? What is happening? So in our last tutorial, we covered more on the strings, how to convert strings to numbers. Make sure that you go back and watch my previous tutorials on the strings, and if you have not subscribed to this channel, please go back and hit that button. So in this part, we shall be continuing with reading files. How can we create a file and read it using Golang language? So this one, we shall go to, as you can see in my screen, we have created a reading file. Then the reading file we have main.go. So let us do it now practically. Okay, so in this matter, I want to start with showing you the creating the file main.go. After that, we shall be writing the how to write a file in Golang, then how to read it. Okay, so these are two ways: you write it and read it from the file. Okay, so in this matter, remember that we start our Go package main and FMT, not FMT but func main, and in our func main here, we have to write another function. We need two functions in this matter. We need function to write and function to read our file. So we shall be starting with function write file. So function write file like that. Then in this matter, I have to pass function write file. We can do FMT, not FMT. Then I need to import this one automatically. FMT like that. Dot print ln. Let us check if our function is connected. Then you can say writing file, and you can do go run main.go. In this matter, we need to check our file. We have not called this function to our main, so I have to copy this one and call it here. Then I can now repeat can cancel this one and repeat the process of calling our Golang again. So this one is going to print writing a file in our console. So that one is checking if our function is running well. Okay, let us see what will be printed on our file there. Yeah, writing file. So we are going to write a file in our in this file. You are going to create a new, like, may not go, but it will be like a text file. Okay, so this is how we go about it. We have created the function. So after creating the function, we have to import our OS library, and the OS library consists of it is a library that helps you, it consists of several. So OS package, it is designed to help you to interact with the system code, or to create files, or to read files. That's the purpose of OS library. Okay, so as we continue, we are going to I'm going to remove this one, and we are going to create our file. I'm going to call it file. This file, we are going to check error when creating a file. Then we are going to assign it to os.create. It should be os.create file. Okay, so this creating, we can call our file name text or test.go, test.t tsx txt, like that. So os.create, as you can see, this one file is not imported. Let me import it automatically from this declared but not used. Yeah, I want to import it like that. So os create, os, it will help us to create. Still, it will help us to read file from the code. So we have created like that. Then we can check error. If error is equal to nil or is not equal to nil, we can say fmt, or we can say return. We can say return. So we can say return error in our code there to check the error. So you can say return error. Okay, so error, if error is not equal to nil, we can say return error. Else, we can now defer dot close. We need to close now our file. It should be capital close. Then it should be file dot close. Defer file dot close. Okay, so our Golang is complaining. I shall check what is happening there, because it is saying return too many return value have error. Want this one. So the error is here. We have to write the message that we have to declare our message here and say our message is type of string. Then now we can return error, because returning error like that, the Golang will stop complaining. Okay, so in this matter, we shall now going to check error. If there is no error, we are going to write our message. Okay, so I can say I ignore the error as we write our message. I ignore the file name. Then we can now say is equal to file dot write string, write string, and the part of this writing string, we pass our message, the message here. So after passing our message, we now check the error again. If error is equal to nil, is not equal to nil. Nil means 0. We can say return error. Okay, so then we can say if all those are there is no problem in our code, you can say fmt prints ln. Printing ln, you can say file created successfully. Then you can say return nil. Okay, like that. So error expected. Oh, I should remove this one there so that the Golang should stop complaining. Then I add comma here. Yeah. So with that, we have now created the code for writing for writing our file. So let us make this code run in our main.go file now. In our main.go main.go in this part main.go code, or inside the main file, or inside the main heart. I call it heart of the go. So to run this file, we need to check the file which is written. Okay, so we can say error. We need to check error is equal to write.file. Then I can now pass the message. You created your first go file. Okay, so the purpose of this main.go, it helps us to, even though you create many functions, you have to make sure that they're inside dot main, the function main should, every function that you create should be uh, instantiated to the function main. Okay, so if error rate file, uh, you expect to see you created your first go file, so you need to check error. If error is equal to, I can say not equal to nil, and error, you can now say log. I need to import log. I can say log and I don't see log here, but dot f format. In this matter, I can say we failed to write our file. We failed to write our file. Then I can check the format of error. Then I can see error. Then I can remove this equal there. Then this log should be imported as well, like that. I should import it there. So log is imported, and this is our file. So for us, we need to run go run main.go to check if this file is going to be created in the reading file here. Okay, so we need to clear our terminal. So we need to go run main.go. Okay, so by running this one, you can see that file created successfully. So when you go to our reading file me.go, when you go here, you can say you created your first Go file. So that is how you create a Go file in Golang. And I'd like to repeat the process for you. You create two functions, the main one, then you do to func the one that is going to write. You import the OS library that helps you to read a file or create files. Then you create. Then the file name should be uh, you can call your file name any name that you want. Then you check the error. So defer file close. If the file is there is no problem, you defer file close. And error file red spleen. So in other words, the defer helps us to delay the function or to delay uh, the the function before. Okay, if the function delay, it helps us to delay the function to return the value or the parameters that you're supposed to return. So after this one, as you can check, we go to error, we check the error file, then we write string as the type of our message is a string. Then we pass the message, this message. We check the error. If there is no error, we say file created successfully. Then we return nil. Okay, that means there is no error. Then we come here and we write our file. Error, write file. Then we check the file. If there is error in our file, then we manage uh, error handling using the log. Okay, so up to this part, we have written our Go file. So the next part we are going to cover is reading the file. So how do we go about it? Still, we are going to create another function. I'm going to come here, and this one is going to be simple. So I'm going to create another function. It is called func. I can call it read file, or let me read file, like that. Then reading this file, we expect to return string and error, because remember that we created a file of string. So expect string, then expect something to do with error. So in this scenario, we have to cover our code with uh, to enclose our code with curly braces, and then or with the brackets. So we need to check the remember our file is stored in terms of string, so we have to check the bytes in it. Then we check the error still, and in this part now we use the os dot read file. Okay, read file, and I think I should change this one to small to avoid some confusion. And then I can pass the name of the file that we are reading. It's called test.txt, and I have to enclose this one like that. So up there, we have now to check the error. If error is equal to nil, is not equal to nil, this file, this exclamation mark means not equal. Okay, return. We need to return nil and error. We need to return empty string and error. Okay, and then you can now return. Can come here and see, you can see you have a missing return. Then you can say return string in this string, we convert now byte to string, byte, and we check error. Okay, and define error. It is like that. There is no type of error but error. Okay, so in this part, now you are going now to go back to our main file, and then we check now the heading part of how now to read the file. Okay, so remember we have now our file as a text.txt. So to read this file, we have to come here. We have to check the content in the file, and after checking the content, we have to check the error as well. We have to check error, and in this we have to say read file, the function. Remember the function is read file, and read file we need to write. We need to pass our to read our test.txt file. So we need to check error. If error is not equal to nil, and if it is not equal to nil, we need to return log.redo. I can copy this one. Need to return log.redo, and I can see that our Golang is complaining that we have written this one and we have not used it. So we can say fmt dot print ln, then we pass content. Okay, it should be print ln, and in this at this point I can also say fmt dot print ln, and I can say file content. Then I can copy this one and put it here and say reading file. I can still copy it here and say writing content. Okay, writing content. So there's a reading file and writing content. So I can clear mine, and run may.go to check if the file has been created. Yes, as you can see, writing content, file created successfully, reading file content, you created your first Go file. So whatever is written here, the file, our code has checked the file which is created. It has read the file which has been created, and that is how we create files in Golang. Please make sure that you subscribe, and as we proceed to error handling using defer, panic, and recover, we shall cover the next topic about defer, panic, and recover, how to handle errors in Golang. Thank you. Welcome back to my YouTube channel, and today we are going to cover more about error handling in Golang. Okay, and please, if you have not subscribed, go ahead and subscribe to my channel, share, comment, and like. It will help me grow. Thank you. So today we are going to cover about error handling, and we are going to base our argument in these three words. That one is panic, then recover, and defer. How those three key ones are used to manage errors in Golang programming language. So as you can see on my screen, I have created a folder and a file for main package, and I would like to start by the usual way of Golang. We usually say package main and func main, and then those are the boilerplate for a Golang. Okay, so I would like to say package main, and in this package main, I have to write the func main, and this func main, I can write another function. I can say func, and then I can say fmt println error handling. Then I can call this function here. I can say error handle. Like that. And if I've got this function, our function is not going to run because we have to import our fmt format. Import fmt. Okay, so by doing that, then you can do go run main.go to check if our console or our terminal is going to print error handling. Okay, so in error handling, I would like to tell you that Go has an exceptions that allows it to handle the errors, not like the old languages, Java, PHP, JavaScript. They usually used try and catch, or yeah, it was try and catch. As you can see in my terminal here, I have error handling. Okay, so let us proceed to check how these error handling are going to help us to handle the errors in Golang. Okay, so I'm going to check on uh, the, the panic, the recover, and the defer keywords. So in Golang, handling errors and managing resources is integral part of programming. Okay, and the important keywords that I have said is defer, panic, and recover. Anytime that you hear uh, error handling in Golang, just remember three words: defer, panic, and recover. So understanding the defer keyword is used to ensure that the function call is performed later in the program execution. Usually it is a purpose for cleaning up. You can decide that I'm not going to call this function before this function. So the defer keyword helps us to understand which function are we going to call first. Okay. So the basic usage of defer, I'm going to show you here. I can remove, okay, I can, instead of removing, I can say defer here. Then I copy this one. I can say alt shift arrow down, alt shift arrow down. Then I can do error handling 1, error handling 2, and error handling 3. Okay, so in this situation here, the Golang is going to call our error handling function in a reverse way. You see, so the defer is where the resources need to be freed. Some operations need to be performed at the end of the function execution, so regardless of the success or failure. Okay, so I can clear the terminal, then do go run main.go. Let us check. So the first line to be printed out is number 3, 2, 1. So the defer keyword prints out in a reverse way. Okay, so maybe you did not wanted this function to run until it reads. Maybe it is a file that it is reading. You want to manage errors like file error, read something. So the defer keyword, it will help you to make sure that it will run fast before the usual function, or it will close fast before the usual function that is running. Okay, so as you have seen there in my uh, in my practical part, so we are going to check on the panic as well. So what is panic? Panic, I can say it is a build function that stops the ordinary flow uh, of control, and it makes the system to panic. And if the system panics, that means the execution stops and all defined functions in the current Go routine are executed. Okay, so to check on panic, I can create another function. I call it my panic and see how the panic works. So I can create another function here. I can say func, and I can say my panic. And in this situation, I can say fmt print line, then I pass this line will not be executed. Okay, so by doing this, I can remove this one, and because I want to call this function, and I put it here, and after putting this function here, let me rearrange this. I can say refactor like that, so that my code can look better. So it is a format document, yeah, like that, so the code can look better. Then I can call my panic here, my panic. It is my panic. My panic function. And what do you expect when you call my panic function? We the system will not print out fmt this line, and it will not run this function because panic stops the flow control of everything. Okay, so the panic, my panic here, when you call this func panic, then I pass panic. I pass panic keyword, then I say problem occurred. So when the panic keyword, when the panic function is called, it stops, and it stops at this point at line 7. So that means the code in the line 8 and 9, it will not be executed. Okay, so let us see if this code is working. So I have to clear my terminal. So clearing my terminal, I have to, in this situation now, I can go run main.go. Okay, so we expect when the panic is called, the line on number 8 and line on number 9, it will not print out. As you can see, problem occurred. And after getting this at this point, now you understand the purpose of defer, panic, and how they're used to make sure our error handling is well executed. So we proceed to now recover. How can we regain from panic? How can we regain from panic? Because calling my panic will cause the program to panic and print the panic message, and the program will terminate. As you have seen, panic, problem occurred, go routine, it has now stopped there. It has exit status 2. Okay, meaning that the code, the panic was called, it stopped the execution of the code. Now, how can we recover from the panic so that the other code can continue running? So, and this is why the Golang is the best language for networking, because in a networking system, no one should know when the system is down, because the system should manage itself. It should be handling errors and understanding where the problem is. When there's error, it stops and then it continues again. So the recover keyword is a built function that regains control of panicking go routine. Recover is only useful inside deferred function. Note that. So when recover is used outside outside the defer function, it will return nil. So how can you use recover in this situation now? So to use recover here, I can now change this one, the func main. I can now instantiate the recover keyword, the recover keyword in this part. I can say now defer. I can now defer a func. If you have not watched my previous tutorial about closures, please go back and watch. And then I can say if r or any value, then I can say recover keyword. Now what am I recovering? The panic. And if we are recovering the panic, I can say r is not equal to nil, and if r is not equal to nil, we expect to print something we recovered now. fmt print ln, I can say system recovered. System recovered. Then we start a new line, comma, then we check the r. Then in this point now we have to call the defer func for it to run. So the defer func here, we have to call it like that to make sure it is a self-calling function. Then we have now my panic. I can now take this panic and put it here now for there. So what do you expect now at this point? We expect our system is going to print panic, but the system is now going to continue. It will have now to treat this line will not be executed. Now this line will be executed. Okay, let's see. I have to clear my terminal. and then go run main.go file, main.go file. So we expect if our system has recovered from error, we expect my panic to show, and if the panic has shown, we expect now, yeah, system recovered, problem occurred. Okay, system recovered, problem occurred, FMT, this line should be, this line will be executed. We expect our system to continue FMT. So when we run this function, we expect to get the FMP print ln error handling. So for this function to run, we have to remove them here and put them here. Therefore, to make sure these code runs well and the recover key and the panic is now executed, but it is not stopping or it is not altering the process of running our system. So when you run this one, go run main, not go. This one is going now to print out everything, and the panic keyword will be there. System recovered, panic occurred. So it will tell you that there was a problem in the system, yes, and the line will be executed, and the execution continued. So this is how now the error handling in Golang works. Okay, use defer keyword inside the recover to recover the system from the panic. Please make sure you subscribe and share, because I'm going to cover more on the panic recover and defer keywords, on more about the error handling. Thank you. What's happening? Welcome back to another tutorial about Golang logging. So what is Golang logging? I would like to know what is Golang logging. So Golang logging is the practice of recording important log event and information during the execution of the Go program. Additionally, it helps developers to track what their program is doing and fix issues and understand how it behaves in different situations. So it helps developers to debug a big systems or big code. It helps developers to know where the issue is more easily. Okay, as you can see on my screen, I would like to show you practically how to use logging. Okay, so how to handle logging? Usually we have to start with our package main, not package logging out, package main, and then we proceed to func main. This is our the function where we shall be running our other functions. So we can create now a simple function to show you what is how to use logging. So I do func, I can call it simple logging, like that. This one should be func, not fun. And then after that we have to use, let me see, fmt. I have to import fmt. So fmt, it should be imported. It's okay, I'll have to import it manually. Print ln then I can check, I can say simple logging. logging. I think that one seems to be good. And then at this point, now I can say log dot print ln. Remember, print ln should be capital Ln. Then I pass and say can say hello world, which is usual, and I can alt shift down arrow. Then I can do here something else. I can say simple error occurred, like that. And then for this function to run, I have to instantiate it in the main function, because when you run our function, it will be func main. So this our function cannot run because we have not imported our fmt in this manner. You have to import this one, and I'll have to import it manually. Import fmt. Then I can import log as well, like that. Then I can go run main dot go. Okay, so as you wait for the logging to show there, so having well dot logging strategy is crucial for debugging, monitoring, and getting insights into application behavior. So it helps you to understand how the application is behaving, because the application will be showing you the messages or the problem that it is facing. Okay, so usually we have to check for warning, for error, for fatal, and for debug. So there is a standard logger, a package that is being used to help the log package to function well. So in this matter, as you can see now, we have package simple logging, hello world, and simple error occurred. It shows you the time the error occurred, the time it was logged out, so it can tell you at this time the system was down, something happened. Okay, so let us continue and check more advanced way of using logger. Okay, so in this at this point, I can now create another function. I can say func formatting logging, and then I can pass now. I can say, let me copy this one here, and for this matter, I can now use the pointer. Then say like val warning. Then this warning is a pointer. Then the type of it is log.logger, like that. And then I can now instantiate this warning. I can say warning is equal to log.new. Okay, at this point I can now pass the OS. I have to import this standard library, like that. It will be imported. Then standard out std, like that, comma. Then I can now check I can tell the system to warning, comma. Then I can now check the log date, .date, LDate, shift I, I can check log time, L time, like that, and log short life. Short life. Okay, like that, as you can see. So in this matter now, I can say log short life. It is okay. Have I written it? Okay. So I can do warning dot print ln, then I can do alt shift down arrow, then I can do a message here. This is a warning. Warning 1, alt shift arrow down. This is a warning 2. Okay, so I think with that I can clear my terminal, and then we can now run go run main.go to check the printout for this one. Okay, so we expect to see a warning. This is a warning message 1, this is a warning 1 or warning and warning 2. Okay, so in this oh, there's a comma here. I have to put a comma here, like that, and that a comma should be there. I can clear my terminal again, and now run the system again, and run the system again. Let's wait and see. Log short life is not else short. It's not short file, not live. Sorry for I have to clear. I don't know why I wrote short live. It should be short file. Okay, we expect to see L world, simple login, warning. Oh, we have to call this function here. The logger one, we have to carry this function to this point so that the main function can, like that. And now we can now clear the terminal again. Yeah, I think at this point it should now show you the result. Warning message 1 and warning message 2. For these line 34 and line 35. Okay, yeah, as you can see now, these are warning 1 and these are warning 2. So the system it will show you the warning 1 and warning 2 occurred at this time, at this date. It will show you, the system will indicate for you how those or how the system is behaving. So let us do another example of opening a file or creating a file and see how the logging can help us to know if the file has been created or the file has not been created. Okay, So I'll have to create another function. Allow me to copy this one I have created here. This one. And then I can do some changing. I can change this function to another. I can say file logging. File logging. Changing it to file logging. fmt println simple logging warning. We have now to check the file. We have now to file error open file. This file we can call it test.txt like that. Now we have to make it simple like that. And then file argument is not enough. I don't know why it is saying like that. Okay, I'll have to check what is happening. os.ocreate create, and then I can do os dot o row name, and then I can append now the file by doing os dot o append. Then you can give it a byte number. Simple. If I declared and not used, it's okay. Then let us use now the file. I'll have to remove this one. I don't want this one. So we have to check the error. If error is equal to nil, or if error is not equal to nil, we expect to do what? To fmt dot print ln, and then we can say failed to open file. Okay, so at this point you have checked the error. Then now we can return empty like that, return empty. And then let us now create something that I call pointer. The similar to this one. I'll have to copy this one, var log, and put it here. But for this one I'll have to change this one to log file, and then logger like that. So log file, let us now log file is equal to log.new new. Then now you can pass a file, comma, then you can say in a message there, comma. Then now you can say you can copy this code here and put it there. So in this at this point now we want now to print out. I can copy this one, warning, then put it here, and then change this one to log alt like that. Then I can edit at the same time, log log file like that. Then I can say this is error message 1, error message 1, and I can copy this one and put it here to show you this is error message 2. Then I can copy this one down, Alt Shift arrow down, then I can change this one to 3. Okay, var log file, okay, log file is a known word, I don't know why. Then I can say now fmt dot print ln print ln. Then I can say, let's say assume our file is created, then you can say done like that. So I don't know why our file is not showing. It is showing that file log file, why is it log file is a known word? Let me change it to camel casing. Let's see, maybe it will help. I can say alt, then change this one like that. Yeah, it was just naming the word, the naming of the variables. Okay, so I can now clear the terminal. It is clear terminal, and then I can do now go run main.go. So we expect when this file is the system, when it runs, we expect to see a file that is created with this is error message 1, this is error message 2, and this is error message. And then this our code is not running because you have not instantiated it to the main. You have to copy it and put it here like that. Then now we can now clear the terminal again. Now go run main.go to see if the file has been created in our system and which message. Yeah, as you can see, there's a done message here. And if you open our login, you go to this one, you can see there's a file that has been created. This is error message 1, this is error message 2. So system can show you what is happening in the system. There was error messages, there was error message 1, 2. That is how you utilize logging. So I'll be talking more about the slog and more packages of logging. But in the next tutorials, make sure that you subscribe and share my video. And thank you for watching. What's happening? Welcome back. So in today's tutorial, we are going to cover about Goroutines. And if you have not watched my tutorials, my previous tutorials about other topics, please go back and watch. Make sure that you subscribe to my channel. That matters to me. And leave a comment, and you can share as well. So let us dive into Goroutines. So what is a Goroutine? Goroutine, it is a light threading in Golang that helps the program to run concurrently, synchronously. So the meaning of the word synchronously, it is at the same time, at the same time. So the result can be shown at the same time. Okay, but how can you implement Goroutines in your programming, and when to implement them, and what time and why? Okay, So let us dive in this tutorial and see how to use Goroutines. Okay, so I would like to start by telling you that in Goroutines we shall be covering 5 synchronous topics. That one is weight group. We have mutex, RW mutex. We have channels and selected cases. Okay, so I'd like to start with the first one. That one is weight group. And before diving into weight group, I want to show you a simple Go routine program. As you can see on my screen, let us start on a simple Go routine program. So I'd like to start with package main. Then our function main, and then in this I can say fmt dot println, then I can say start, and then here in the second line I can say go. I can pass a function which we have not created. I can say go count, and this count is a function from which we'll have to create a function for count. I can say runner 1, then I can duplicate this line, shift alt down, and then say runner 2, and then I can say fmt stop, fmt stop, fmt dot println, just be capital println, then I say stopped. Okay, so we'll have to come here outside this function in our function main, then we create another function. This function is called count, and then we pass our value, and the type of our value is string. You can do int string or any other type that you want. Then you can say fmt println, then I say value, or this I can say value started. This one is a string started. Okay, so what is the output of this code that we have written? Okay, we expect we have a type of error here. This one should be capital, like that. So I think our code is okay now. Yeah, so let us run this code and see the result in our go run main.go. So the result that we expect from this code, you expect to see only start and stopped. Okay, because the other one are the go routines, and the go routines, they are not, the two go routines line 7 and 8, they are not going to show, because go routines was unable to complete the execution and terminating the moment the main routine stopped. Okay, so the problem can be added in two ways: using a temp package to add delay in the main function. Okay, so as you can see, you have start and stop. We expect to see this one. So as you can see on my screen, we have start and stopped. Why? Because the go routine stopped the moment the main function stopped. Okay, so to solve this problem, we have to use a time package. And how to use the time package? I would like to show you how to use the time package in this scenario here. So the time package helps our system to sleep a little bit, like 1 second or 2 seconds, to allow the execution of the routines. Okay, so this is simple. I have to come here and do time dot sleep, and then I pass time times second. Okay, second. You can say event times 1, and this one should not be time part dot second times 1. Okay, so the time package should be imported. Time package should be imported there. So this time package here, this one delays, it delays our system, our code. When this one delays our code, it allows the routines now to be executed. Simple. So let us now do again go run dot main dot go run main dot go. So in this way, now we expect to see the result of runner 1 and runner 2. Okay, so clap for yourself that you have solved the problem of Go routines and how to run uh, your result concurrently, synchronously. Okay, however, so why it is not showing? Oh, I have implemented the time sleep in the wrong. So this one should be here. This one should be here to allow this line 17 to sleep a little bit for these line 13 and 14 to be executed. So I have to clear my terminal, and then after clearing my terminal, then I can do go run main.go. Let's see if the problem now has been solved. We expect now to see start runner 1 started, and value started runner 1, runner 2 started, runner 1 started. So you can see now we have solved the problem of Go routines. So I would like to ask you, have you understood how to use time package to make sure that Go routines? Yes, but time is not the best way to use while executing the Go routines. So that's why we have the weight groups. As please make sure that you subscribe, like, and share as we now go to the weight groups. Let's see how weight groups can help us now. Maybe run more than 2 Go routines in the same code. Okay. As I have said that time package is not the ideal way of dealing with Go routines. So let us see how the weight groups can help us understand how to make sure that our Go routines run synchronously. Okay, so to handle these, what are the weight groups in Golang? Golang weight groups allows you to block a specific code block to allow a set of Go routines to complete execution. In other words, weight groups allows you to block a specific code to allow a set group of Go routines to complete execution. So an example would be like a block of main function until the Go routines are completed and the main unblocks the group. So weight groups is available as a standard package and can be imported from the sync package. Okay, and I would like to tell you that for free we have 3 methods of weight group. That one is add. What is add method? What is weight method? And what is done method? So the weight method, the weight group acts as a counter encoding the number of functions or routines to wait for. So when the counter becomes 0, or the routines are being executed, the wait group receives the routines. The wait method blocks the execution of the application until the wait group counter becomes 0. Okay. The done method decreases the wait group counter by a value of 1. So it makes the system to panic. That shows that the routines has been executed. So it's time to say done. So those are the 3 methods that wait group uses. So the question that comes in, how do wait groups solve concurrency programming Golang? So let us do it practically, and make sure that you subscribe, share, and leave a like for my video. So let us do it practically now on my screen. As you can see, how do wait groups solve the concurrency problem? So let us do it practically now. Allow me to allow me to delete this code, then I can start again. Package main. So I have to function main, and then I pass the wait group now. So there's 2 ways that you can call wait group. I can say val wait group, and I declare the type of wait group is sync dot wait group dot wait group like that. So the other way that you can declare this wait group, you can say YG equal to sync dot wait group. Okay, this is the first way, this is the second way. So the first way and the second way, they are almost the same. Okay, so I'll have to continue the first way, and the first way, then we have to know how many routines are we having in our system, assuming that you remember that in the first code that you have written, that we had, yeah, it is not used, it's okay, we had 2 routines. So how to make the wait groups to understand that we have the 2 groups? Remember I talked about the add method. So this is where the add method comes in. So add method. So in this add method, I'll have to tell my code to wait for 2 routines. And the 2 routines is go count, and go count, I can say runner 1. Let me make it a string. Runner 1, like that. Then I can duplicate this code, this line, then I call this one runner 2. So the moment we have said add 2, now the system has understood that we have only 2 routines. Okay, then I can say fmt, and then this fmt dot print ln, then I pass start. I can say start. This is where our code is starting. So we have told that our program understands that we have only 2 routines. The first one for 15, line 15, and the second one line 16. Then in this part here, we have now to try to sleep our system. So which method sleeps our system? So sleep our system. our code or sleep our program. So to sleep our program, we have to do weight group dot weight. This one should be weight. Okay, so these methods make sure that the two goroutines that they're up there, they have been executed. So the wait function, it will be the one to signal this line. Now you can continue with your execution. Print ln, then you can say stopped. Okay, so this one is similar to time sleep. Okay, so let us now create our function here, count, so that our Golang can stop, our program can stop complaining. And then we pass a value. This value is type of string. And then we pass now our weight group. So our weight group, it will be passed as a pointer. Okay, I have covered about the pointers in the previous tutorials. Please go back and watch more about the pointers. So the pointer here, it's type of sync dot weight group. Okay, and then now as we can now say fmt print ln, and then we pass now the value. You can say value, then started. Okay, then change this one to capital, started. So our system now has started. Okay, so we want to capture all the values in our Goroutines, and to do that we have now to let us create a simple for loop. Maybe we want to for loop as a simple for loop. Let me say for I, this I is equal to 1, then I less or equal to 5, and then at this point we can say I'll increment our I, so that one is I plus plus, and then we do like this. We say value. Now we want to do fmt. We want now to assign our value, print ln, then we say value I. So our value should, it is now to I, comma, we pass our value as I. So this value started, so it will be 1, and 1 started runner, and then we have to instantiate the pointers in this way, yg, and then this one yg, not wg, not yg. Then we have to put a comma here so that we can pass the values there up. Okay, so as this code, as you can see here, now we want to tell our fmt print ln started, 𝐒𝐴𝐧 complaining, unused parameter wg. Okay, you have to use it. Let me check why it is complaining, because I can see on my screen, oh, we have not tell our function to stop once everything is done. So this one is yg, not yg but wg dot done method. Okay, so this done method, stops our program, and we want to make sure that our done method stops the program completely when everything has been executed. So for this matter, we have to use defer keyword. So you have to say defer. So go back and watch what I said about defer and how to use them. So defer means it will be executed the last. So defer done. So the system now stops at this point. Okay. So we have wg.add means we have two routines. In case we want to add another routine in this scenario here, let me show you so that you can understand what I mean by add method. So add shift down, then I can say 3, and then I change this one to 3 because now we have 1, 2, 3 routines in our program. Okay, so I think now everything is okay. Let us now run our program and see the results on the screen. So it will be go run main.go like that. Now we expect our program to understand that we have only 3 routines, and these routines sleep our program wait. Okay, and as it wait to be executed, these program it will be like started value started. Then we expect our value, we passed our I to value, so it will be yeah good. So it will be started 3, it started with 3, it went to started 2, and started 1, as you can see on my screen. Good. And it will be 1 2 3 4 5 6, and the 2 1 2 3 4 5 6, and then it is stopped. Is that not good to understand how to use weight groups? Is not that good how to know to solve uh, concurrency using the weight groups? Okay, so I would like to give you an assignment. Go and read more about the weight groups concepts, understand the programs with routines, implement examples for weight groups. Make sure that you subscribe and share this video because I'm going to cover more about the channels and how the channels are used to communicate between two routines.